Chirag bhai, please mute others.
Yes. Good day, everyone. Okay.
Hello, everyone. Jai Jinendra, Jai Ramji, Jai Shri Krishna, Happy Hanukkah, Merry Christmas, Salam Alaikum, everyone. I'm Pankaj Shah, and I want to thank you, all the scholars who have been receiving a flood of emails from me since last year and a half. And I want to thank you, all the scholars, for staying with us in spite of all this long stretch of pandemic, providing me their PowerPoint presentations, abstracts, and papers on time. I would like to take this opportunity to specially thank Dr. Sulek Jain and Dr. Manoj Jain. Since this idea of symposium was conceived nearly a year and a half ago, Dr. Sulek Jain and Dr. Manoj Jain, they provided constant inspiration, encouragement, and support for the symposium. And with the help of Dr. Sulek Jain, he brought other two international philanthropic organizations to support us, Sir John Templeton Foundation and Ubrai Foundation. So with the support of these two international foundations, this symposium truly has become an international symposium on Jainism and mathematics. With this, I would like to welcome the President of Jain Center of Greater Boston, Haresh Bhai Tamboli. Thank you.
Jai Jinendra, everyone, and welcome to International Jain Math Symposium.
Jai Jinendra, I would like to welcome everyone to the virtual International Symposium on Jainism and Mathematics. As a president of the Jain Center of Greater Boston, बोस्टन में आप सबनु भावभर्યું स्वागत છે. बोस्टन में आप सभी का हार्दिक स्वागत है. We initially had planned to have the symposium at MIT in Boston, but as we all know, due to the pandemic, things have changed and we had to move all our events this year to the virtual space. We are still hoping to have in-person symposium at MIT in the future. I would like to thank Symposium Committee, Jaina, and especially Sri Pankaj Shah, our chairman of the board, for leading this international symposium effort. JCGB's history goes back a lot further. Our Jain community started off from just an idea in 1973 with a few group of families consisting of all Jain sects and mostly young members starting their families. During the 1976 Mahavir Jayanti program at MIT, Acharya Shri Sushil Kumarji put forth the idea of having our own building, and we soon became to known as the first Jain temple in Northern America. Acharya Shri Sushil Kumarji was present at the inauguration of our Jain Center. We have had a strong connection with Jaina throughout the years and have put emphasis on our youth as well. The JCGB Pathshala dates back to 1982 as the first Jain Pathshala in North America. We are proud to have a part in hosting this symposium. As many of you know, ancient Jain literature contains advanced mathematical topics on number theory, set theory, the theory of series and sequences, logarithms, trigonometry, as well as the concept of infinity and zero. such mathematical concepts are deeply embedded in small details of karma theories, the universe, and the Jain study of celestial bodies. With this brief introduction, I now would like to invite Dr. Manoj Jain as a session chairperson for today's event. Dr. Jain is born, raised, and educated in Boston and is a faculty member of Emory University in Atlanta. He regularly contributes informative articles about public health in leading newspapers and magazines. He is the son of Dr. Vinay Jain, who is one of the founding members of the Jain Center of Greater Boston. As a family, they have been heavily involved at JCGB, both as regular attendees and financial contributors for many years. We are excited for his presence and contribution here today. Please let's all take a moment to welcome Dr. Manoj Jain.
Thank you very much, Jai Jineend, everyone. Jai Jineend, and welcome to our first Mathematics Jain Symposium. My name is Manoj Jain. I'm an infectious disease doctor and taking care of many COVID patients during this pandemic. I also regularly write for the Washington Post. But probably the most important thing about me and about what we are doing today is the very fact that Jainism and mathematics are about to be married in a unique way. I am an ardent follower and promoter of Jain values and Jain way of life. I am also today the proudest person to be a member of the organizing committee for this first Jain International Symposium on mathematics. So, to begin our program, I would like to invite Preeti Jain, the host of opening ceremonies. Preeti Jain is the past Pathshala director and has been teaching Pathshala for past 30 years. She has choreographed several cultural programs for Jain Center of Greater Boston and Jaina, and has been an integral part of several Jain Center of Greater Boston committees. So let us begin our program with the opening ceremony with the host, Preeti Jain.
Jai Jinendra, my name is Preeti Jain. I am from Jain Center of Greater Boston. We would like to open our today's program with Namokar Mantra being presented by the EC members of our Jain Center. Let's start.
ॐ नमो अरिहन्ताणम् नमो सिद्धाणम् नमो आयर्याणम् नमो उवज्झायाणम् नमो लोये सव्वसाहूणम् ऐसो पंचनमुकारो सर्वपावपणासनो मंगलाणं च सव्वेसिं परमं हवै मंगलम् परमं हवै मंगलम्।
We would like to continue our program with a prayer to Dwadashangi, which are our agams. The agams were compiled by the 11 Gandharas, or the prime disciples of Bhagwan Mahavir. Those acharyas, with their infinite mental capacity, carried the Dwadashangi in their powerful memory. The Dwadashangi is magnificent. Like a lamp, it illuminates everything that's worth knowing. With bhakti, every day I revere to Dwadashangi as it holds the essence of all principles in the entire universe.
अर्हद्वक्त्र प्रसूतं गणधर रचितं द्वादशाङ्गं विशालम् चित्रं बहवर्थयुक्तं मुनिगणवृषभैर्धारितं बुद्धिमद्भिः मोक्षाग्रद्वारभूतं व्रतचरणफलं ज्ञेयभावप्रदीपम् भक्त्या नित्यं प्रपद्ये श्रुतमहमखिलं सर्वलोकैकसारम्
We would like to continue our program with the second prayer, a salutation to Goddess Saraswati. Goddess Saraswati, who is pure white, like jasmine, like the coolness of moon, like the brightness of snow, like the shine of white bright pearls. Goddess Saraswati, who is sitting on a white lotus. Goddess Saraswati, who is covered by white clothes, who is holding a veena. Goddess Saraswati, who has been adored by Bhagwan Vishnu, Bhagwan Brahma, Bhagwan Shiva, and all other devas. O Goddess Saraswati, O Goddess of knowledge, please protect me and remove my ignorance completely.
तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शंकर प्रभुतिभिर्देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजायापहा।
We are fortunate to have blessings from Jain Acharya, Sri Vijay Nandi Ghosh Suriji. Nandi Ghosh Suriji became a monk after completing high school. He has mastered Sanskrit, Prakrit, and Ardhamagdi. Suriji has immense knowledge of Jain astrology with a good understanding of celestial mechanics and modern astronomy.
श्रीमते वीरनाथाय सनाथाय अद्भुतस्य मानन्द सरोराज मरालायार्हते नमः। कृतापराधे विघ्ने कृपामन्थरतारयोः ईषद्भास्पर्धभद्रं श्रीवीरजनेत्रयोः वाणी त्रिवनसामिनी श्रीदेवी जखराय गणविरगा गौरीशिवाल सुरेन्द्र सया विरक्षन्तु दिनवत्ते Achinta Chinta Manikalpa Sakshine Visuddha Satbrahma Samadhisaline Daya Navaya Sritadayine Satam Namo Namaste Gurune Misudaya Namo Namaste Gurune Misudaya. Respected all scholars, many blessings and dharma to all of you. It is with great pleasure that I am giving my blessings for the success of the first International Symposium on Jain Mathematics at MIT Boston. I send my best wishes to all speakers and I thank to the symposium organizers and all committee members. This international symposium promises to shed light on specially Jain mathematics. We will learn about various concepts and theories regarding Jain mathematics. I also hope the symposium will encourage us to further our studies of Jainism. May we all find success in our continued research of various topics within Jain studies. With best wishes and blessings.
अर्हद्वक्त्रप्रसूतं गणधररचितं द्वादशाङ्गं विशालम्.
Welcome and Jai Jinendra.
Now, Dr. Anupam Jain, would you like to give the brief introduction?
Pankaj Bhai, I'll can you hear me? It's Dr. Manoj Jain.
Yes, Dr. Jain.
Okay, so let me then do a introduction and introduce Dr. Anupam Jain. So welcome everyone. I am a student of science, but I absolutely love math. You know, math is logical, sequential, progressive. It is zero, it is infinity. It is positive, it is negative. It has rules and it has laws. Jainism is also logical. It's pragmatic. It explains the natural phenomena that we see each and every day. It espouses the belief that the universe operates under rules and laws that cannot be violated. Jainism has a theory of life, the biology and the chemistry. Jainism has theory of soul. Jainism has the theory of karma. And Jainism has a theory of moksha. Jainism, at its core, is body, the soul, karma, and salvation. Over the next few days, what you and I will be hearing is how these two vastly different yet similar fields, Jainism and mathematics, what they have in common through the centuries and millennials that we have gone through. So, the purpose of our conference is to elaborate upon the new areas of research in the field of Jaina mathematics and to highlight the distinct features of Jain mathematics in ancient Jain scriptures. How did we come here? What was our journey to the Jain Mathematics Symposium? I want to take a few minutes and reflect on those processes and this journey that we have come to. The idea was seeded in the mind of Pankaj Bhai Shah. Over 2 years ago, he had been looking at this in great detail. He's a nuclear scientist, and as you can see in the background, he has all of the plans for a nuclear power plant, which embodies many mathematical principles. But he had not realized that the depth of those were also within Jainism, a religion that we all espouse. It was my father who then connected us. And then I recall that we made a call to Anupamji Jain in Indore. Phenomenal connection was made. And then the whole process snowballed. We began to connect to people in ways that we had not thought we could do under a common theme of Jainism and mathematics. We connected with Dr. Sulekh Jain, and we brought in the Jaina Liaison Committee, also with Dr. Devrat Shah from MIT, and we had a hosting institution at the Massachusetts Institute of Technology. But we needed scholarly pillars as well, in addition to Anupamji Jain. And there, with Surendra Jain from Ohio, who was a great asset to our scientific organization committee, along with Ken Pugh and Catherine Maurice Singh from Paris. And that made the team complete. So today we get together virtually, but soon we will be getting together in person as the pandemic begins to wane down and the vaccine begins to be available for many people. With that, I would like to introduce Dr. Anupam Jain. He's a scholar of mathematics. I had the pleasure of meeting him at a pre-conference conference in Indore a year ago, and he has been an absolute asset in our ability to bring all of the scholars together today. So, Dr. Anupam Jain.
Thank you, Manoj Bhai. Respected Acharya Shri Nandi Ghoshji, Namostu. Respected Chairperson, Dr. Manoj Jain ji, Jain Center of Greater Boston, President Harish Bhai Tamboli, Professor Dani, and dear friends. In this Mangalacharan inaugural function and the first day of International Symposium on Jainism and Mathematics, being the first speaker, it is my duty to congratulate Jain Center for Greater Boston for organizing such a good conference symposium on this important topic. Naturally, two other organizations, Jaina and two foundations, both are associated with us. Now I come on the topic. Some idea was given by Dr. Manoj ji, but being a man of the mathematics, I would like to say that Jain literature is very vast and varied, and mathematics is an integral part of the Jain literature. Great Jain mathematician Mahaviracharya say, Bahubhirvi pralapaikim Trailoke sacharachare yat kinch dostu ten ganiten bina nahi. So this indicates the importance and usefulness of mathematics in studying the Jain literature, and in fact, without the knowledge of the mathematics, Jain literature cannot be understood well. Jainacharyas are not intended to develop the mathematics, but they use the mathematics as a tool to explain the cosmological detail and the philosophical thoughts, especially related with the Karma theory. To facilitate the readers, Jain scholars and Jain acharyas created absolutely mathematical text like Ganit Sar Sangra by Mahaviracharya, Trishatika by Sridhara, Ganit Tilak by Singh Tilak Suri, and Vyavahar Ganit by Rajaditya, Ganit Sar Komdi by Thakkar Feru. In this way, we got that the entire Jain mathematics, or Jain school of mathematics, or Jain school of Indian mathematics can be divided in the two parts. Number one, canonical class. Number two, exclusive class. In the canonical class, we find the mathematics which is embedded with the canonical text, and it is used to explain the philosophical thoughts or the karmic theory or the cosmological details. Now, first day is devoted for the canonical class, the mathematics of related with the canonical text or the mathematics which is found in the Jain canons or their commentaries. I am happy to note that Acharya is here to speak on the enigma of zero. A very senior scholar and the past president of Indian Society for History of Mathematics, Professor S.G. Dani, will speak on the geometrical concepts available in the Jain canonical text. Dr. R.S. Shah will focus on the overall development of the mathematics in Jain canonical text. And Dr. Anthony Ruda will focus on the Jain logic, because there are so many purposes for the development of mathematics in Jain canons. One is the cosmological details, cosmological model, another is karmic model, third one is the logic, and fourth is the astronomy. Pankaj Bhai is doing a lot on this field, in the field of astronomy, and another is the general mathematics, which is used in the construction of the temple and houses. My students, Dr. Pragati Jain and Dr. Jitendra will speak on the set theoric approach and the type of infinity available in Jain canon. So in this way, there is a lot of diversity in today's session, but the main focus is the Jain canonical literature. I hope that we will enjoy this session and we increase our knowledge in this very field, because history is a growing subject. As in every conference, in every symposium, we get some new facts, and they all will build up the Jain school of mathematics. So finally, I welcome all the scholars and congratulate to the organizers. Thank you. Jai Jinendra.
Jai Jain, and thank you, Dr. Anupam Bhai. Now let us begin with what you have all been waiting for, hearing our scholars. So our first presentation is by Dr. S.G. Dani from Mumbai on Jaina geometry, its uniqueness and influence on other traditions. Just as a house rule, I will ask our presentations to be no more than 20 minutes. I will interrupt you if you are going, because I want to be mindful of the time. And also, if you finish early and there are questions in the chat, we will address those, or we will address some questions at the end. So, Dr. Dani, please, thank you so much.
And just one humble request, if you are speaking, please start your video so that way we can make sure that you are spotlighted for all the viewers. Thank you.
Yeah, hello everyone. I have started my video and I hope it's visible.
Yep.
Right. Okay, very good. Let me begin by thanking the organizers at the outset for this opportunity to speak on Jain mathematics. Especially my focus is going to be on geometry, its uniqueness and influence on other traditions will be some of the themes that I'll be elaborating on in the limited time that we have. Now, can we go to the next page, please? Can we go to the next page, please? Yeah, sure. So as Professor Jain already mentioned, the cosmological contemplations of the early Jain scholars gave rise to motivation for geometry, and various geometric ideas were developed. Even early manuscripts such as the Chandra Prajnapti, Surya Prajnapti, then Jambudvipa Prajnapti, and then later Devma Swati's work on Tattvarthadhyogama Sutra Bhashya. These are some of the very early compositions which already have a good deal of geometric content, and that's what we are going to go over this time. In addition to the early works, I mean, there is a second important phase in the Jaina contributions to mathematics, and we have scholars like Sridhara, Veerasena, and Mahaviracharya, whom Professor Jain, Anupam Jain quoted. And later again, a few hundred years later, in the 14th century, there's also Takura Feru, who was involved. All of these later people were also, apart from their work in geometry and mathematics in general, they were also involved in a big way in promoting mathematics in the Indian context. So the mathematics, which until that period was somewhat limited to certain particular segments of scholars and people involved with astronomy and so on, was taken to a broader scale with a variety of people, including artisanry, trade, and so on, and with a lot of the pedagogical work and compositions, etc. The Jaina scholars contributed greatly to the rise of mathematics in India during this period. So our aim here will be to present and discuss the significance of the ideas involved here from the development of historical perspective. Let's go on. Let's move on. Yeah. So one of the very notable features of Jain geometry is square root of 10 as the factor for obtaining the circumference to the diameter. In all the early cultures, as one would often have the Bible and maybe some other cultures, it was often taken, the ratio was taken to be 3. Roughly, the people said the circumference is 3 times. But some of the very early corrections came from the Jaina tradition, where the square root of 10 was taken to be the correct, more appropriate value for the ratio. So this Jambudvipa Prajnapti, this is actually transition can actually be noted. So after recalling the traditional factor of 3, which is involved in the ratio of the circumference and to the diameter of the mandalas, I need not go into what that means for this audience. So there's a transition to saying that the more appropriate value is a square root of 10 as the accepted value. Now, this is not only just a notional thing, but using this value, in fact, very elaborate calculations are done with regard to circumference of the Jambudvipa, which is the Earth, which corresponded to Earth that we live on. And the diameter of that is supposed to be 100,000 yojana. So the circumference was calculated as the square root of 10 times the square of 100,000. So that's and it's calculated. We'll not spend time on the details, but it's calculated well to quite an accuracy, which has been commented upon very favorably by many scholars, including Western scholars. Let's move on. So square root of some comments on the ratios. The square root of 10 comes out to about 3.16. As we all know, in the modern value for pi is about 3.1416 ... I mean the unending decimal expansion. it was the Jaina scholars were also among the first in across the globe, one I would say, who to recognize that the ratio of the diameter, the circumference to the diameter, is the same as the that of the area to the square of the radius. So these two, in a way, these two are independent mathematical constants, but they turn out to be equal, and that had to be discovered on the course of rise of civilization. And one of the Jain scholars were one of the early people to have taken that step. Now, about this factor square root of 10, I should also mention that the same factor was adopted by Chinese scholar Chen Heng. Also spelled as the Chinese names often have two variants. Zhang Heng is also another way of pronouncing that. And in China also, not surprisingly, the early value was associated with it was 3, and Zhang Heng corrected that to square root of 10. Now, I would postulate that this period suggests that, in fact, the adoption of this value in China would very likely have Indian roots, because this is about the period when there was a lot of communication between India and China, especially with it's very likely. I don't. We cannot say we have any specific evidence, but that the Chinese value adoption of this is also is from of Indian origin. Now, though the value was prevalent primarily originally among the Jainas, it was also adopted by the Vedic the scholars in the Siddhanta tradition, coming from arising from the Vedic tradition. So Brahmagupta and others were also used the value square root of 10. Actually, a more accurate value, 3.1416, is described in Aryabhatiya of Aryabhata in the 5th century, but that value is not found used in their practical applications. And usually, people typically used square root of 10. Today, for instance, we tend to use 22/7 rather than the decimal value of pi. So in view of that, in fact, it's square root of 10 is commonly known as the Jain value of pi. And it continued to be in use until about the 15th century almost. I mean, so it's a very popular choice, and though one needs further evidence on this, it also seems that along with Indian arithmetic and the astronomy, etc., the value of pi also was incorporated in Arabic mathematics, and onward later on in Europe also the Jain value square root of 10 was used for the ratio of circumference to the diameter. So let's move on. Now, we do not know how the value was, how they thought of the value. It's of course, something that one would naturally tend to speculate about. And the question itself also has a long history. There's it was already has been discussed by Madhavachandra Traividya, who was from around 1000 of our common era, and in his commentary on the work Tiloyasara of Nemichandra. So there have also been other suggestions. People have various other people have wondered about it. There's a classical suggestion by Hunrath. Then there is the work of Chakravarti and Professor R.C. Gupta, was still around, and there's speculation about how it might have been calculated. Sometimes some of them depend on octagons, and some of them depend on the 12-sided regular polygon. One cannot say that any of these explanations are quite satisfactory. So to my mind, actually, the problem still remains, and I do not know whether it will ever be possible to work out. But whatever postulates these people have made are of some interest from a mathematical point of view. So we'll be discussing more of that in the paper that's going to be presented. So let's move on with this. Yeah. So one of these
Dr. Dani, I think your internet may be a weak signal.
things to are the formulae which in his announcement. But am I audible now? Am I okay?
Yeah. Yes, you are. Please continue.
Okay. Yeah. So here are the formulae. So D is the diameter, C is the circumference, A is the area, and so let me look at the formula there. C, the first one written there is simply rewriting of this ratio of the circumference. We'll not dwell more on that. Second is the area. The third is about the relation between chord and the H is the arrow. So when you have the bow figure, there are two things: the chord, then there is the arc, and the thing that joins them is along the arrow, that the segment joining the midpoint of the chord to the midpoint of the arc, that is the arrow, and this gives the relation between between these three. And there's also a variant of that which is in Formula 4, and there's also another variant which describes D in terms of the other two. Now again, we do not know exactly how they have. These are I have listed in this first part. I have listed only the exact formulae. These formulae are exact, though we do not know how they would have been arrived at. So a couple of possibilities are that this may have been realized from understanding of similar triangles and the proportionality of sides of similar triangles, which is the classical belief about how it might have been achieved. There's also another possibility that there are various reasons to believe that the theorem of Pythagoras, that is for a right angle triangle, the hypotenuse squared is equal to the sum of the other two squares. This was known to the scholars. So unfortunately, we do not find any specific mention in any of the works. It is clear from various formulae that they would have been aware of this formula, and it's one of the thing that I am putting forth is that this actually would have been derived from that. So with this, let's go forward. And now there is a more intriguing formula, and that's about the length of the arc. So let's go back to the idea of the bow figure. So there you have the chord and the arc, and one would like to relate the length of the arc to the length of the chord, and possibly including the length of the. So from the measure of the chord and the arrow, one would like to understand how much the chord length is going to be. And this is an interesting formula that given in. So much of this, actually, the standard reference goes to Uma Swati, but the formula would be from Surya Prajnapti and perhaps also Chandra Prajnapti and so on. So the formula is that the arc squared equals the chord squared plus 6 times the square of the arrow. So and it's written in the form of a square root here. So there's also an equivalent formula of how to derive how to get h in terms of the other two. So though various formulae are listed, they're not all independent. The one derived from other, etc. We'll not go into that aspect. The suggest knowledge of the straight path joining the endpoint of the endpoints of the chord. So there's a triangular path. The length of that will have 4h square rather than 6h square that we see here, and the arc has to be longer. So the suitable constant had to be found. And if one notices, if one looks at how much it should be for the diameter, then the factor 6 comes out neatly as the right value if we take pi as the square root of 10. So there's a very neat description of how this how it would have been thought about. I mean, there's no first of all, this is not an exact formula, so it cannot be a proof for that. Now, interestingly, a similar task was before faced by the Greek engineer Heron of Alexandria. He is from the 1st century, and he had proposed a couple of formulae. Now, in my paper, I'll be making a detailed comparison of the various formulae, and there are various for various angles. The Jaina formula works better, while for some others, Heron's formula is closer to the area. So, on the whole, while we do not know how
Gadani,
the formula would have been
minutes.
arrived at, okay,
Yeah,
the
five
formula
minutes,
fares quite well. Yeah, let's go further. As was mentioned earlier, there's after the first phase in the early centuries and the pre-common era, there's some lull for some centuries, and then there was a second upheaval, and we mentioned various names. It might be good to keep in mind that during the interim, there was the rising period of the Siddhanta astronomy, Aryabhata, Brahmagupta, from the period which sort of intervene the two. So and that gives a certain background. So this intervening period had given rise to interest in mathematics in a certain sector. Those people involved with the astronomy, I mean, and its applications, like the prediction of eclipses, then preparing almanacs, etc. But the task of and so by then there was some rising interest in the at a popular level in mathematics. The learning itself had been limited to a particular segment, and the work of the Jaina scholars spread the idea of mathematics around. So let's go to the next page. Next page, please. Yeah. So here I'm going to content myself with works of a few Jaina scholars. So one of the prominent names is Sridhara. Unfortunately, there has been some confusion about whether Sridhara was Jain or not, and what was this period, etc. But fortunately, I think it's these issues have now been settled, and now it is one knows that he was a Jaina scholar. And he also there's consensus now that is from the 8th century and preceded Mahavira rather than the other way around, which was one of the speculations earlier. Now, yeah, so there are two important works of Sridhara, some of which was mentioned by Professor Anupam Jain, Trishatika and Patiganita, and both of them have interesting aspects in geometry. A lot of basic geometry, plus one of the things that I want to focus on, let's go to the next page, is the formula for formula for volume. Now, in the Indian tradition, the credit is normally for the volume of a sphere. The credit is normally given to Bhaskaracharya, who is from the 12th century. So, however, now the interesting thing to note that Sridhara gives a formula in Trishatika, which describes the volume of the sphere as the diameter divided by 2 whole cubed times a factor 1 plus 1 by 18. Now, this by itself automatically one cannot argue is that it will be argued to be the correct formula, but it's very close. And what is important to note is that the factor 1 by 18 is in fact the right factor. So
I think the internet is going in and out, so please bear with us.
At an approximate level. So as I've said here, it would 5 by 3 that should appear there. I don't know. Yeah. So this was as an approximate value. This was a good value. So in a way, Sridhara had one can say had given a correct formula for the volume of the sphere. But unfortunately, this was not followed up even in the Jaina tradition of Mahavira, etc. So that was historically one of the missed opportunities to have been. So let's go to the next page.
Yes, please. And please finish off, Dr. Dani, in a minute or so.
Yeah, right. I'm just going to say a couple of things about Mahavira. In Mahavira, the kshetraganitavyavaharah, there is a part in geometry. It's one of the biggest chapters, and there are a lot of numerical examples which promote the understanding of geometry. And one of the some of the interesting things are it is sort of unique. The shape of a conch, or the shape of elephant tusk, etc. The next page, please. And then in my article, I'm going to focus on one more aspect, namely there's a figure which appears as ayata. In general, have tended to translate this as ellipse. But I would argue that it was not quite meant to be the ellipse in the the limited sense that that we are now used to in mathematics, coming from the Greeks. Because and there are various distinctions about this figure. Again, for instance, the area and the length, circumference of the ellipse, and the area that are described, the formulae do not quite fit with the description. And there is even a qualitative distinction, in the sense that they're not meant to be. There's the symmetry of axis is not implied. So these are what is it seems to me that what is involved is a more practical figure, and perhaps one should look into the correct options for what it was. And I'm going to say a few things about this in my article. Next page. Yeah, here I have said that the Mahavira also has contributions about the quadrilaterals, and this is the things related to Diophantine approximations, which I'm sure many other talks will be covering. So I need not say more about it here. It's just about the quadrilaterals. Now, my next slide. The one final name I would like to focus on is Takuraferu. Takuraferu is a Jaina mathematician who had a significant impact, especially in North India. And he was a polymath, which he had works on many subjects: gemology, astronomy, architecture, metallurgy, etc. And they worked in the court of Khalji Sultans and in Delhi in the 14th century of that time. And the onset of the Islamic culture is sort of reflected in his work. For instance, the things related to minars and so on are seen in the geometric expositions of Thakur Firuz. So this is also something that I'll elaborate in my article. So with this, yeah, I'll thank you all for the your attention.
Thank you very much,
I also
Dr.
I thank the organizers once again.
Yeah, Dr. Dani, superb presentation. Thank you so much. I had not known about the 3 going to square root of 10 as a great advancement, but I do. Next, we have Professor R.S. Shah from Pune on the evolution and development of mathematical ideas through Jaina scriptures. Professor R.S. Shah.
महाराज नंदी घोष के प्रति सादर प्रणाम और सभी पार्टिसिपेंट्स के लिए जय जिनेंद्र. My basic thesis in this paper is to highlight how the various mathematical ideas were evolved and how they were developed by subsequent acharyas, right from canon to subsequent acharyas, etc. And I am covering a period, say, from 600 BC to about 1400 AD, 2000 years. Thereafter, I think our mathematics, there was no much contribution in mathematics. But during this period, there was a great contribution. I think I'm audible to all?
Yes.
Yes, very much so.
I start with my first transparency, and that is Anuyog Dwar Sutra. See, one of the great mysteries of mathematics is who is the discoverer of zero? Who assigned it the place value? And that was a very big question. My studies revealed that the earliest reference is in Anuyog Dwar Sutra. Sutra 490 says about the minimum number of avdarik sharir, that is physical bodies of human beings. And that is, they made four statements very clearly. First, they said the number is of more than less than 32 digits and more than 24 digits between this. Then they actually pinned it down to 29 places, to 29 digits. And they also say that it is equal to 2 raised to 32 into 2 raised to 64. That is 2 raised to 96. And when I wrote down the number, I find that in the thousandth place, there is a zero. There is zero. You can just imagine. So they knew that 29 places, and they also knew that in that place, thousandth place is vacant. Maybe there may not be symbol at that time, but definitely they had the idea about the zero and its place value. These statements also show, just a minute, these statements also show that there was the concept of zero with place value, rules of indices, 2 raised to 2 raised to 5 into 2 raised to 2 raised to 6 is equal to 2 raised to 32 into 2 raised to 64 is equal to 2 raised to 96, and so. So the concept of this also were emerging because they say h is a number which can be halved 96 times. That is log 2 of the h is equal to 96. Okay, next please. Now, Bhagavad Sutra is one of the oldest canons in Jaina scriptures. There are some 2 or 3 very advanced concepts which I am going to talk here. One thing is about the partition of numbers or integer. It is called integer partition. This is a function which is commonly used in statistical mechanics, quantum mechanics, even in pure mathematics, in symmetric functions, symmetric groups, etc., etc. And see how the idea come. It is in the same manner. For example, 4 can be partitioned in 5 ways. 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, 1 plus 1 plus 1 plus 1, 5 ways. our says that it is in 4 can be partitioned in the corresponding 4 ways, because we have not included the original number. 4 we have not included. So our function, partition function, is 1 less than the modern mathematics partition function. Okay, please next. Another very important concept, which is also applicable in atomic physics, quantum mechanics, and all that, is the and probability theory, is the occupancy problem. And see how it has come. The problem is simply that how many ways in which R balls can be put in N cells. How we have tackled it in our scripture, that how many ways 1 or 2 or 3 or 10 souls can enter 7 narkas, 7 hells. And the modern formula is this. Now, probably this formula may not be known to at the time of Bhagavati Sutra, but they have very correctly calculated the values for 1 soul to 10 soul, as you can see 7, 28, 84, 210, 462, 924, etc., up to 8008. And all these are listed. That is a wonder, great wonder in the Bhagavati Sutra. One interesting thing, Abhayadev of 10th or 11th century has used for calculating this, and for calculating in the 12 heavens and or 16 heavens, he has calculated by this recurrence relation. That is a very wonderful thing. That also must be noted. Next transparency, please. Yeah. Another greatest contribution of Jaina Acharyas and Jaina Karma theorists is the theory of infinity, theory of Asankhya and Ananta. There, and one will wonder that how it corresponds just literally to the Cantor's theory of transfinite numbers, which is the most beautiful theory as per the great mathematician Hilbert also. I'm not going to dwell because it is a very long subject, but only I want to say that what Cantor said, that Aleph naught is the minimum infinity. Aleph naught raised to Aleph naught will be Aleph 1, which is the next infinity. Aleph 1 raised to Aleph 1 is equal to Aleph 2. That is the third infinity. Like that, there can be infinity of infinities also. And similarly, the same treatment, exactly similar treatment, is given to Asankhya and Anant by our Acharya. In my main paper, I have given this in detail, so I don't. Next transparency, please. This I am omitting for the time being. My paper will elaborate next year. Now, as Mr. Dani has replied, has explained, that there is a contribution of Jaina in geometry also. As they say, Greek geometry was Greek algebra was geometry, and our Jain geometry is algebraic. It is opposite like that. For example, the Jambudvip is disc-shaped, circular. It is surrounded by seas and islands, which are annular in shape. So, Acharya Yativrishabha in Tulopanati has developed the full geometry of mensuration of circle and annulus, and he has given 19 formulas, which I am not listing here. Only I have given some 5 formulas here, and in my main paper will explain other details. But he has given 19 formulas which are very much algebraic in nature. Yeah, next please. Now comes Virsena's, I have said, rhetorical algebra, because he has not used any symbols. He has merely used words only. And I don't know how they were able to understand without symbols. For us, it is really difficult. That we are so used to symbols that by words we have to exert to understand that. Various formulas, algebraic formulas given. He has given his own remainder theorem in a different manner. Some algebraic relations also he has given, which actually See, these are some, and there are 13 more relations he has given, which are a precursor to continued fractions. What is the theory of continued fractions? I can say it is a precursor of that. He had gone up to 2 convergence. If he had gone further, he could have calculated 3rd convergent, 4th convergent, 5th convergent, etc. Yeah, next please. Now, Virsena has also given formulas for arithmetic progression, geometric progression, and he has calculated the number of moons by some certain recurrence relations. As per our Jaina mythology or Jaina tradition, the number of moons and number of stars, etc., are infinite in number over Asankhya Dvipas and Samudras, isn't it? But he has given formula and he has given in words, but at the kth, any island, say kth island, number of moons mk is equal to, you can see the recurrence relation. And he has calculated also for 6th sea. 6th sea is Pushkar Samudra. There are 11,200 moons, and next some Ikshukar Dweep, etc. There are so many. Now, another amazing thing is that the Shatkhandagam of 2nd century gives binomial coefficients which are attributed to Pascal, the Pascal triangle. But you see here how he was considering the 6-fold increase. Ananta Bhag Vriddhi, Asankhyaat Bhag Vriddhi, Sankhyaat Bhag Vriddhi, Sankhyaat Guna Vriddhi, Asankhyaat Guna Vriddhi, and Ananta Guna Vriddhi. In that, he has given these algebraic relations. And you can see these bold letters, they give the binomial coefficient 1, 1, 1, 2, 1, 1, 3, 3, 1, then 1, 4, 6, 4. And the procedure was so general that they could have proceeded further and the whole Pascal triangle would have been considered. But we give it credit to Pascal of 16th century, but actually it is in 2nd century Shatkhandagam, and further in all other subsequent Karma literature also, this triangle, and it was called Meru Prastha. Of course, Meru Prastha is called so by Virhang and Gopal, etc. Next, please. Now see, this relation, this very important relation is 64 combination. 64 out of 1, 64, 2 out of 64, 3 out of 64, up to 64 out of 64, that is equal to 264 minus 1, is stated in Shatkhandagam by quoting a ancient Ganit Gatha. And the actual figure is not calculated, which is calculated by Virasena. It is some 23-digit number, isn't it? Then these formulas, general formulas, were also given by, for combinations were given by Virasena. Next. In order to highlight, now he wanted to calculate 3 raised to 10, which you would have calculated by simply multiplying 10 times 3 with each other. That is 59,049. But he calculates it just to show the relationship between binomial coefficients and 1 plus r raised to n is equal to 1 plus 2 plus r minus 1 into n. And he has applied the binomial theorem to that. And these are the binomial coefficients. And these are the powers of 2. And he has arrived at that figure of 59,040. And many such calculations he had made in Dhawla, his great commentary Dhawla, a marathon commentary, an encyclopedic commentary Dhawla. Yes, next please. Virasena has developed the complete theory of logarithm with base 2. And he has further remarked that you can have base 3, base 4, base 5, or any base you can develop there. But with base 2, he has developed about 13 formulas. I have given here only 2 formulas here, but there are some formulas very advanced. You will find it in my main paper and in my 48 transparencies, which I sent you earlier. Yeah. Please, next. Virsena has gone up to not only log, log of log, log of log of log, and log of log of log of log. Log of log is called Varga Shalaka. So Varga Shalaka of Varga Shalaka. And simply log is called Ardhached. And this he has developed so immaculately that one wonders how in those days this was possible. Now, this is a very important fact, and I want you to notice, everybody to notice it. See, Virsena just missed calculation of the limit E of Euler. E is equal to 1 plus 1 upon factorial 2 plus 1 upon factorial 3 plus etc. etc. Instead, because he was preoccupied with finding out what is when the thing becomes double. In that process, e raised to ln 2 is equal to 2. It becomes double. So he has calculated the natural logarithm of 2, the natural logarithm of 3, the natural logarithm of 4, which is from those days, it was a very advanced thing and nobody could have thought of. It was only calculated in 17th or 18th century by Euler for the first time, actually. Maybe Newton also must have calculated it. So you can just see. So what happens? He says log 2 is equal to 41 upon 56. That is 0.73214287 in our, if we expand this. Actual value as per mathematical value is 0.693, which is just 6% higher than the actual mathematical value. He finds log 3 as 64.5 upon 56, which is 1.15, and actually it is 1.110, 5% more. Most wonderful, he calculates ln, that is natural logarithm of 4, which is 79.5 upon 56, which is 1.41. Actual value is 1.38, which is just 3% more than the actual value. So for those times, it was a really wonderful thing. In my main paper, I have given entire logic, and how he has derived this also is there. Next, please. Next.
That was the last slide, Dr. Shah.
No, I have given some 2-3 more.
That was the last that I have, unfortunately. Sorry, sir.
Yeah, I saw actually.
So go ahead, why don't you talk through it and then we will add it up.
I'm remind that. Okay, only I want to just tell that this is the, okay, sir, okay.
Please continue. You have time to discuss some of the other ones.
If any questions, I will glad to answer.
So thank you, Dr. Shah. It was really, truly amazing listening to you, and especially the way you were able to show that zero was really known to our Jaina mathematical scholars. Just looking at, if they looked at 2 to the 96th power and 0 is in there, and that it had to be known to them, otherwise it would not have existed in that. And also how you looked at the soul and the hell and the connection, that how many souls would be going, and they had all of the formulas already pre-known to them.
Number of ways.
Yeah, and how beautifully it was done in there. And this is exactly what our conference is about. It is to be able to interpret what our mathematical Jain scholars knew in light of what we know today, and to give them due credit for their work as well. So with that, I want to introduce our next speaker, but before that, Professor Rajmal Jain from Ahmedabad, who was going to talk about measurement of space and time in Mayan and Jain tradition, will not be speaking. But next will be Dr. Pragati Jain, who will be speaking on Manavar, along with Manavar and then Dr. Anupam Jain, on the set theoretical approach in the Devala commentary. So Dr. Pragati Jain, Dr. Manavar, and Dr. Anupam Jain. Please.
Namastu Acharya Shri. Honorable members of organizing committee, valued participants, speakers, and all delegates. Jai Jain to everyone. In the present era of science and technology, the set theory has become an indispensable part of all the sciences. And in this connection, the Dhawla commentary of Acharya Veer Sen has a fascinating system of characterizing the idea of a set and its categorization, which is incredibly engaging and immense. And thus, this is the reason Dr. Anupam Jain and I chose this topic. Professor Shah in the previous lecture has covered number theory, basic operations of mathematics, laws of indices, and logarithm covered in Dhawla. I will be focusing on the set theoretical approach which was covered by Acharya Veer Sen in Dhawla. To begin with, next slide please. To begin with, let me remind what Anupamji Jain said in the beginning, that mathematics is an integral part of Jain literature, and mathematics developed by Jainacharyas or the mathematics found in Jain literature called Jaina mathematics. Looking into the importance of mathematics in ancient India, the Jaina literature was divided into four main classes: Prathamanuyog, Karnanuyog, Charnanuyog, and Dravyanuyog. According to this subject-wise classification, Jaina mathematics mainly comes under Karnanuyog, that includes cosmology, cosmography, astronomy, and karma theory. Jain Prakrit texts that belongs to Karnanuyog group, like Tilok Parinati, Jambudev Panati Sangho, Lok Vibhag, Trilok Sar, Shatkhandagam, Suri Pragyapti, Chandra Pragyapti, they play a very, very significant role to understand the development of knowledge presented by Jaina scholars in ancient India. And these texts give a significant treatment of basic mathematics as well as applied to the Jaina karma theory with a mathematical approach, and describes the various units for measuring distances and time with the help of which the universe and all the fluents and their events are measured. And thus, it also gives the description of the number measure. Next slide. There is a rich convention of science among Jainas, Acharya, or we can say scholars contributed all together in the field of science. Acharya Sridhara, Acharya Mahavir, Singh Tilaksuri, Thakkar Peru, Yati Vrashab, Nemi Chand, Madhu Chand, and Pandit Totarmal can be associated with this overview. Acharya Veer Sen is one of them whose name goes ahead the top in the rundown of philosopher mathematicians. Basically, he was not a mathematician, but he used mathematics as a tool to accomplish the religious ceremonies. And to know more about the life background of Acharya Veer Sen, one can go through the articles written by Takao Hayashi, published in Jin Manjari in 1996, and Jain Agam Gyan Rath Ke Sarthvahak, written by Surajmalji Bubra in 2007. Can we have next slide, please? Thank you. Dhawla Tika is a commentary on Shatkhandagam, 1st century AD, of Pushpadant and Bhutbali in Prakrit language, written by Acharya Veer Sen in 816 AD. He had written 72,000 sloks, or we can say gathas for Dhawla, and 20,000 gathas of Jai Dhawla commentary, which is completed by his pupil Acharya Jinsen. As per information available in the ending lines of Uttar Puran, one more commentary of the book entitled Siddha Bhupaddhati, which was written by Acharya Veer Sen, but at present it is not available. The Dhawla Tika is treated as Agam in Jain community, particularly in the Digambar tradition. The mathematical material contained in Dhawla may be attributed to the previous writers, especially to the previous commentators, Kundkund, Shamkund, Tumbulur, Samantabhadra, and Bappadev. Thus, Dhawla becomes a work of first-rate importance to the historians of Indian mathematics. This commentary, originally published by Jain Sahityodharak Fund Vidisha Amravati, and afterwards by Jain Sanskriti Sangrakshak Sangh Solapur, under the editorship of H.L. Jain and A.N. Upadhyay in 16 volumes in Hindi language. The slide shows the cover page of Dhavla Volume 3, which contains a rich mathematical content. H.L. Jain has denoted the date of the fulfillment of Dhavla as 8th October 816 AD. Next slide. Moving further, let us compare the concept of set theory. Chapakop shamak yort vitvam kimiti neshchitai ti chain gunani bandhana nivratti parinaman sammi pradarshanath tadekatvo katehi. Here, the collection of Jews having similar property is considered as Gunisthan. This concept is similar that of present concept of classical set theory in modern mathematics, which was given by George Cantor in 1895, that a set is a well-defined collection of objects. Yeah, next slide, please. The fundamental word basic to Jain mathematics is Rasi, which appears to have phonetic correspondence with the Greek word for ratio. The synonyms used in Dhavla for the word Rasi are like Samuh, Og, Punj, Vrind, Sampat, Samuday, Pind, Abhin, and Avshesh. And similarly, some other words like Mitchaiti, Kodi, Buddhatam, Savaloge, and Vagna. They also sound as sets. Here, the sets are mainly divided into three categories: soul set, particle set, and time set, that will be described in the later slides. Next slide. The sets are classified into various categories. Under unitary elements of sets, the 6 fluents, that means dravya, form the natural units, and they are soul, material, ultimate particle, non-material ether, material anti-ether, time particle, and space. The practical units are instant, point, individual corresponding section, instant effective bond, and vector. If we talk about fixed fluences, the set of all souls, that is the complete Jivrasi. The set of all ultimate material particles, that is Pudgal Rasi. The set of all time-informed particles, that is Kalanu Rasi, form fixed fluent sets. If we talk about instant sets, then the all-time set, the past time set, the present time set, the future time set, the infra 48 minute, that is Antar Muhurt set, the trail time set, that is, we can say Avali, the creation time, Kalp set, and so on. Many more examples of instant sets are available in Dhavla. Moving further, if we talk about null set, yes, the conceptual set containing no element is the null set. For example, the instant set of the past may be said to have been exhausted by the soul set of the wrong faith souls. The finite sets are either summable or non-summable. The point sets of a soul, the non-material ether, the non-material anti-ether, the universe, space, etc. are the examples of non-summable finite sets. Yes, the energy level of controls, that is gun of fluence, are measured through the number set of the individual corresponding sections. The foundation of measure rests on the number of units or elements contained in any set. The cardinal of the set may then be defined through the number measure of the fluent elements. The basic measure are ordinal or summable, non-summable, and infinite types. Further, these are divided into various ranges. The cardinal measure is of 8 types. Time fluents do not form a body here. Hence, each of them forms a single point set. The set of individual corresponding sections of knowledge in omniscience is the greatest set. And this also implies the set of all the knowledge sections of all the omnisets. And the concept of union of sets is also inherent here. There are sets of souls in 14 control stations. And these stations help in giving a deep and extensive study of the topology of sets, of souls in various living, wayward, and other stations. There are two types of active groups of matter, that is Pudgal Vargana, the inner and the outer one. These are important so far as a survey of a structure of material form is concerned in medical and other sciences. There are sets of souls in 14 control stations, I said that. And the set which cannot become a null set by being exhausted for unending time has been called transfinite by the great sets. The set of all souls, the set of points in all space, the set of instants, a few examples available in Dhavla. Moreover, the karma structures are classified as sets of merits, demerits, eternal portal, restraint portal, and emergent portals, all in terms of becoming of mundane souls and their corresponding karma particles. Various types of becomings of living and non-living beings are in the form of variable sets also. Souls in various control and wayward stations also form variable sets, since soul enter, stay, and leave them in flow of time. Yes, next slide, please. The method of 1-1 correspondence was used by Virasena for comparing transfinite sets. He used 8 analytical methods for illustrating and exposing the measure of sets. And they were measure, reason, explanation, abstraction or extra creation, cut, division, separate, and removal, or we can say subtraction. Comparability, that means alpa bahut, of summable, non-summable, and infinite types of sets is one of the methods of analytical studies into the knowledge of order of smallness or largeness in relation to several tattva. Here the comparability is of two kinds, the soul and the bond particle. And again, it is described in two ways according to time and soul. In order to locate the order of comparability of all finite and transfinite sets, 14 types of sequences with the first term, the last term, and the other corresponding station terms are described. There are 14 kinds of series also, some arithmetical and some geometrical, as Professor Shah said in his previous lecture. They are described fully in later text of Triloksa. Yes, Dhavla did not describe them, but utilized many of them in its calculation, especially while illustrating the calculations related with abstractions. Their use indicates that Virsen was familiar with the arithmetical and geometrical progressions. And Virsen applied the method of abstraction while dealing with the dyadic sequences also. He categorized the abstraction into two parts, lower and upper abstraction. And further, it is divided into many more categories. Next slide. This slide shows as one of the examples of bhajit, that is division. The mentioned equation here is geometrically presented as an application of areas. ABCD represents L square, and division was considered in terms of, you see, the set theoretical approach. Similarly, the dealings with the fundamental operations also are in terms of rasis. Yes, next slide. As it is remarkable that, yes, the dyadic sequences, continued fractions, formula for finding volume, and surface areas of several unique geometrical figures, the basics of advanced mathematics like quantum theory and probability, etc., are nicely presented through the sets. In addition to this, the notions of logarithm under the name ardhached are also available in Dhavla, which has already been discussed in brief by Professor R.S. Shah. We find examples related to log base 2, 3, 4, and 5. But however, yes, in modern mathematics, we are using log to the base e and base 10. Next slide. In a nutshell, the Dhavla commentary of Acharya Veersen offers to ascend to different explanatory strategies. Yes, and other crucial mathematical concepts developed through the operations on sets that mark an indigenous contribution of the Indians right from the era of science and developing. Veersen not only utilized the contemporary mathematical process, but he also made many new points and processes during his days. It could be evident that a substantial amount of studies on Jaina mathematics have led to modify many of the views of modern mathematics. It is clear from comparative studies that Dhavla has a specific position, especially in the field of set theory. Moreover, it is noteworthy that for every set, there is a number associated with it, and that gives the sense of the measure of a set or cardinality in modern mathematics. Sets relating souls, their becomings, nature of karma, the number of particles involved therein, along with their intensity of reactions and stay periods, are available in Dhavla. And in the form of, it is very interesting that in the form of doubt and explanation, the sense of fuzzy set is also assumed. It is quite amazing. Next slide. Yeah, we have used these references. The slide shows all the references. And as far as set theory in Jaina School of Mathematics is concerned, L.C. Jain has done excellent work. Next slide. Yes. The incredible researcher of Jain philosophy, Narendra Prakash Jain, informed that a copy of Dhavla manuscript is stored in Sri Chandraprabhu Digambar Jain Temple, Firozabad, as the slide shows. So this is the copy of manuscript of Dhavla. Next slide. Profound thanks to all the organizing committee members. Thank you all.
Thank you very much, Dr. Pragati. A fabulous, fabulous presentation. I really loved the way that you categorized the scriptures and where Dhavla is within that. You give us a just sort of a living example of one of the scholars, Acharya Veersena, and it almost felt that we were meeting him in person. As well, you provide us with the basic theme that math is a tool for religious ceremony, and the depth of Dhavla, as well as the taxonomy slide as well. So thank you so much. We are doing very well on time. What we would like to do is to do a 10-minute break. I know we're all on different time zones, so I cannot tell you what time to come back on. But let's do a 10-minute break from now. We will come back and then begin our presentations again with Dr. Omkar Lal Srivastav and Dr. Smita Srivastav after that. So 10-minute break. Thank you so much.
Meanwhile, I think attendees can ask questions in the Q&A form so that we can pass on to the scholars and you can get the answers for anything that you have in your mind during these three presentations. Thank you.
अगर कल ना मिले तो समझ लो कि ये कुछ ये भी चाहता है पैसे.
One suggestion can I give?
Yes. Yes, please go ahead.
No, Pragati Jain had very nicely described about the set theory in Jainism, but she should have given some examples of intersection of sets, union of sets. For example, main set is Abhavya Rashi. Subsets are Mithya Drishti Rashi is the main set, then subset is Abhavya Rashi.
So Dr. Shah, may I just say this? Let's take a break and then we'll come back to those conversations. Would that be okay?
Okay.
Yeah. So because that will get everyone to hear it and then we'll get her to respond. So we'll just take complete the 10-minute break. Yeah.
I believe there was one more question. Will slides be posted on some site so that can be reviewed? So like that is by Mr. Ashwin Doshi. So obviously like Pankaj Bhai or Anupam Bhai, we cannot hear you. So sorry. You may want to take off yourself from mute.
Yes, I will post all the PowerPoint presentations on a Google link so everybody can see. Even before, after the all, I don't want to preempt the PowerPoint presentation before the presentation, but after all the presentations are done, I will share the Google Drive link to all the participants or anyone. So you don't need to take a note during the PowerPoint presentation. After the presentation, I will send the Google Drive link to everyone where you can see all the PowerPoint presentations.
There is also one question on chat from Mahendra Maru. Are we able to get actual papers speakers are talking about?
Now we have a plan to compile. Professor Surendra Jain, he will take a lead in compiling all the papers that will go through extensive review by professionals. So all the proceedings will be published sometime middle of the next year. All right, so can we start? Can we have some music with a temple video, please? Haresh Bhai or Dev Bhai or our.
Yeah, we will do that.
And let's relax everybody with the good Jain temples all over India, and relax with the good music, good background music for a few minutes, and then we'll reconvene after a few minutes. Thank you.
Harish Bhai, I can play that.
Okay. Yeah, I was just opening it actually. But yeah, you can be fine.
Temple video, temples. Like to see temples.
Welcome, everyone. And we will get started again. So fabulous set of presentations on our first part of this, I should say evening or morning. I will leave that up to you. And now we have our second set of conversations. Our presentation next is by Dr. Omkar Srivastav and Sumita Srivastav from Rajnandgaon. It is on Mersenne primes in the Triloksara and Gomatsara. So please, Dr. Srivastava.
Jai Jinendra to everyone. Honorable Acharya Vijay Nandi Ghosh Suriji Maharaj, Namostu. Respected chairperson and renowned scholars. I am going to talk about Mersenne primes in the Tiloesar and Gomatsar. Co-author of this paper is Sumita Srivastav. Next slide, please. Next slide, please. Mathematics and astronomy are integral parts of Jain canonical literature. Smith in 1908 and Rangacharya 1912 found rich and resourceful guidelines from Ganit Sar Sangrah, earliest Indian text whose name is entirely devoted to mathematics, of Mahaviracharya of 850 CE. Research on Jain school of mathematics received an impetus after the work of Datta and Singh, later on Bose, Sen, Subbarayappa, H.R. Kapadia, Needham and Ling, Sukla, R.C. Gupta, L.C. Jain, Agrawal, Jha, Hayasi, A.K. Bagh, Saraswati Amma, Lisk, Anupam Jain, Deepak Jadhav, and myself to light several main contributions of the Indians to mathematics and especially the contribution of Jainas to mathematics since 400 BCE. Next slide, please. Mersenne primes. In this paper, we will discuss in particular numbers of the form 2 to the power p minus 1 is equal to mp, where p is a non-negative integer. They are called Mersenne primes, named after the French monk Marin Mersenne of 1588 to 1648 CE, who first studied numbers in this form. In the preface of his Cogita Physico-Mathematica of 1644, Mersenne claimed MP is prime for P is equal to 2, 3, 5, 7, 13, 17, 19, 31, 67, 127, and 257, and composite for all other primes which are less than 257. Next slide, please. Mersenne's list could be checked completely till 1947. It was established that Mersenne's list was not accurate because he excluded P is equal to 61, 89, and 107, and included incorrectly 67 and 257 in his list. The correct list was for n is equal to 2, 3, 5, 7, 13, 17, 19, 31, 61, 89, 107, and 127. Next slide, please. This slide is showing the historical development of first 11 Mersenne primes. It is taken from the Mersenne organization on primes. Here we can see that the Greeks are also used Mersenne primes in 500 BCE, and Euclid also used in 275 BCE for 2 to the power 3 minus 1 and 2 to the power 7 minus 1. And after that, in 1456 and onwards, the Mersenne primes is discussed by many other peoples for making perfect numbers. Next slide, please. Survey of Literature of Nemi Chandra. The paper of B.B. Datta, Mathematics of Nemi Chandra, 1935, is the first published work on Nemi Chandra Siddhant Chakravarti. The research work of Professor L.C. Jain, Professor Anupam Jain, Deepak Jadhav on Nemi Chandra are noteworthy. The PhD thesis of myself on the mathematical contribution of Nemi Chandra Siddhant Chakravarti is useful for acquiring knowledge about him and his contribution to mathematics. Next slide, please. Next. Contribution of Nemi Chandra Siddhant Chakravarti. He was flourished in 1975 CE, was a great Jain scholar of Talakad, Shravan Belgola, Karnataka. He has done mathematical and symbolic treatment of the Karma theory in the Digambar Jain school. He wrote 4 texts in Prakrit, namely, first is the Gomat Sar Jiv Kand, which contains 734 verses. The Gomatsar Karmkand, second is, and it contains 972 verses. Third is the Tiloesar. In Sanskrit, it is called Triloksar, and it contains 1018 verses or gathas. And fourth is the Labdhisar, including Chapdasar, which contains 653 verses. Next slide, please. Tiloesar. The text Labdhisar of Nemichand Siddhant Chakravarti is regarded as a final companion text to be taught in continuation of the Gomatsar Jivkand and Karmkand text, and before all these mathematical foundations are required to be laid down through a study of the Tiloesar, the Labdhisar, the Gomatsar Jivkand and Gomatsar Karmkand, as well as the Chapdasar, succeeded in holding the field of study of the functional theory or Karma theory. The Karma theory needed a symbolic treatment which appears to be in full swing in the detailed commentaries of the Gomatsar Jivkand, Gomatsar Karmkand and Labdhisar. Next slide, please. Gomatsar. Commentaries on Gomatsar Jivkand and Gomatsar Karmkand were compiled by Keshav Varni in 1359 CE in Kannada. These are said to have been based on the Veer Martandi commentary of the Gomatsar Jivkand and Gomatsar Karmkand, compiled in Kannada by Chamund Rai, who was a scholar and devotee of Jainism, the commander-in-chief and prime minister of the kingdom of the Western Gangas during the reigns, at least, of Marsimha II, who is 961 to 974 CE, Rajmal IV, 975 to 984 CE, and Raksha Gang. Chamund Rai was contemporary of Nemichand Siddhant Chakravarti and his great devotee, and got constructed 57 feet high, superb Bahubali Colossus at Sravan Belgola. Next slide, please. Now, I want to discuss the relevant verses of Tiloesar. Here in Tiloesar, chapter 1, Gatha number 55 says, Beadi bi uttariya keval panjataya samadhara savat avar mavaram runukas mukkasam, means the sequence which initiates with the 2 and goes on increasing with 2 up to the omniscience, means infinity or nth term of the series, is called the event sequence, means samadhara. Next verse. Egadi bi uttariya visam run keval vashana ruva jud mavar mavaram varam varam hodi savat. It is given in Triloksar, chapter 156. Its translation is, the odd sequence, Visamdhara, begins with the digit 1, Egadi, increasing with 2, means B, means 2, and Uttariya means increment as common ratio 2, and multiply to again and again, Varam Varam, ends with the omniscience, means infinity or nth term as reduced by unity, Ruun. It means we can find odd numbers by subtracting 1 from the every term of a geometrical progression series, and first term 1 with common ratio 2. Next slide, please. Duppahudi ruv vajjid keval nana vasan makdiye ses vihi vismam va sapdudam kevalam thanam, means the non-square sequence initiates with 2, Duppahadi. It is called as Duppahudi, and goes on up to omniscience, Keval Nana, means in a term as reduced by unity, Ruvavajid, the remaining process, Sesvihi. It is called in Prakrit Sesvihi of this sequence is like the odd sequence process mentioned previously in the Triloksar chapter 156 Gatha. It means we make a sequence of powers of 2, like 2, 2 square, 2 to the power 3, 2 to the power 4, etc. up to 2 to the power n, and reduce the last term by unity, that is 2 to the power n minus 1. So we get the numbers like 2 to the power p minus 1 is equal to mp, where p is non-negative integer. And we have shown previously that these numbers are same as Mersenne primes. Next verse, sir. Next. Now we are going to show some verses, relevant verses of Gomatsar Karmakand. इट्ठपदे रूणे दुग संवगंभी होदी इट्ठ धणम असरिच्छाणम तर्धणम दुगुणे गुणे सगी सवधणम. It means the non-square sequence dug sam vagambhi by multiplying 2 in every previous term for getting desired term. Ittha dhanam. In Sanskrit it is called ishtadhanam of sequence, and subtracting unity ruunne Sanskrit rupon from desired term ittadhanam, we get a new number which is not same. It is called here in Prakrit asarichanam tadhanam, Sanskrit asadris namant dhanam. It means if we make a sequence of powers of 2 and reduce, just like previously, reduce the last term by unity, we get numbers like 2 to the power n minus 1, which is same as Mersenne primes given in Tiloesar chapter 159 also. Again, next slide, please. Now we discuss our result. The extensive study reveals that none of the scholars who have done research on ancient Indian mathematics and astronomy have found Mersenne primes in any Indian text till now. Whereas Greeks from 500 BCE to 275 BCE have used prime numbers up to 2 to the power 7 minus 1 for making perfect numbers only, but they have not got any general terms. Nemichan Siddhant Chakravarti is the first Indian who has discussed in detail and given general term 2 to the power n minus 1 for prime numbers in history of mathematics of India. Next slide, please. Conclusion. Above discussion reveals that Tiloesar and Gomatsar both have described prime numbers as well as Mersenne primes explicitly. Thus, it is clear that Nemichan Siddhant Chakravarti of 975 CE used frequently Mersenne primes. Many centuries earlier, Marine Mersenne of 1644 CE. So it is noteworthy contribution of Nemichan Siddhant Chakravarti to mathematics and number theory about prime numbers also. Next slide, please.
I think this is the last slide.
Ji, thank you, sir. Thank you very much, sir.
Thank you very much, Dr. Srivastav. If you would like to add some more background on this, but I find it fascinating how you were able to look through and find that the Mersenne primes, which were by the monk in 1600 in France, and how they were related 600 years earlier by our Jain scholar, Nemichan Siddhant Acharya Chakravarti. This is truly what we are looking at from this conference, is to be able to, at the first step, be able to find the jewels of mathematics that are and known relevant to us today, that were present in our scriptures many years ago. In addition, we wonder if there are still hidden jewels in Jain mathematics that modern day computers could utilize, that modern day mathematicians could reconstruct their thinking. So that is to all of our wonderful scholars, to have them to be thinking about that you are taking Jainism and Jain mathematics to a new step. But what would be really helpful is to have individuals at your caliber to take this to the next step, which is to help modern mathematics. Sunil Jain had mentioned some of that in his chat, that how do we make Jainism relevant today? So with that, I would like to go next in our next presentation. And
question.
Yes, sir.
To Mr. Srivastava. Mr.
Yes,
Srivastava, observation.
Yes, sir.
Yes,
yes, sir.
N minus 1, they are all not prime. What
Yes,
limit
sir.
wants
It
to
is
say
true, sir. Yes, sir.
they are odd numbers.
Yeah.
They're the one
They
of
are
the
all not prime, sir, but
so they are
yes.
odd numbers. They are all odd numbers, isn't it?
But yeah. But he
second very important. I am very sad when I observe that none of in entire Jaina literature, in Jaina mathematics, there is no mention of prime numbers, there is no mention of conic sections, and there is no mention of regular polygons, etc. Although they might have calculated root 10 by polygon methods, but there is no mention anywhere in this. So to say that they knew Mersenne primes, I think it is not correct.
Yes, sir.
It is not correct. They knew that they are prime numbers, Mersenne primes. That is not correct. That is my observation.
But he has told, sir, in a verse that there is avibhag pratichhedo. In a verse, he is saying avibhag means prime number, sir. Avibhag pratichhedo means that is a prime number, and he has used many times 261 minus 1 in his mathematical part of sharing the philosophical thoughts. 261 minus 1 is a prime number, sir.
Avibhag
Just like that is a Mersenne prime.
Not prime. Avibhag pratichhedo is the indivisible ultimate unit.
Avibhag means, sir,
common
it is
term.
not divisible. Avibhag means, sir, not divisible. That is not divisible, actually.
Indivisible ultimate unit.
Yeah. So Dr. Shah, I very well, good point. And I think it might be the conversation of more detail. Very good observation and very good insight into this. And one can, talk about what is you call it a prime number, is it indivisible? And we can discuss this more in depth. But I do want to continue with our program. And I really appreciate the engagement and would ask our other speakers also to continue being engaged with questions such as this. If you cannot ask them right away, please do write them down and we will come to them. And I can promise you, with the superb presentations and the engagement that we have had, we are going to continue the dialogue. Right now, we do want to continue with our presentations. So,
Manoj Bhai,
yes, please.
I would like to give another very small, brief introduction of Acharya ji. If you
yes, please. Absolutely.
When you are ready.
No, we are ready, sir.
Okay. I would like to give Preeti Ben. She gave an introduction of Acharya ji, Nandi Ghosh Maharaj Sahib. Again, I would like to add just few more sentences with regard to Acharya ji. He completed his high school graduation. Then he self-taught himself. Of course, he is very good in Sanskrit, Pali, and Ardhmagdi and other scriptures, but he also self-taught himself the English. In English, he also compiled a couple of books on scientific principle of Jainism. And then he is a very good in Jain astrology. He is probably the best Jainacharya in all over India with regard to the Jain astrology. And he also taught himself the basics of celestial mechanics. So he does understand the real concepts of astronomy, not only the astrology and astronomy. And so I just would like to again admire this Guruji. He also doesn't mind taking a bold steps and saying that, yes, some of the scriptures that we have in cosmology and astronomy, perhaps they need to be relooked, reevaluated. And so he has earned very high regard from all over the Jain community. Mathain Vandame, Guruji.
Darula. Zero and enigma. Next slide, please. There are some familiar facts regarding zero, but till today, zero is an enigma for ancient and modern mathematicians. Who invented zero? Did Aryabhat invent zero? First reference in the manuscript is the Bhaskali manuscript. We find the zero as the point. Next slide, please. The Jambudvip Pragnapti is the sixth Upang, which was compiled during this Vallabhi Vachana 454 AD. The Jambudvip Pragnapti, Surya Pragnapti, Chandra Pragnapti, Dvipsagar Pragnapti, etc. agamas belong to the Ganitanuyoga. In this agamas, large portion is occupied by mathematical operations concerning Euclidean plane geometry on a large scale, like Jambudvip, having a diameter of 1 lakh yojanas. In this agamas, all mathematical operations were performed in a decimal system before the birth of Aryabhat. These agamas were compiled in 454 AD, 22 years before the birth of Aryabhatta. Next slide, please. Next. In the pious leadership of Devadikanik Samasaman, 500 acharyas have written all agamas on palm leaf at Valbipur after the 980 years of the Nirvana of Lord Mahaswami. In this agamic literature, 12 angas and 12 pangas are main, but during Arya Sulibhadra, 12 agama named Drashtivad was forgotten. So 11 angas and 12 agamas were put on the palm leaf manuscript. Next, please. This has been originally mentioned verbally by Lord Mahavir 6th century BC, while Euclid was born around the mid of 14th century BC and died around the 3rd century BC. So prior to Euclid, Lord Mahavir mentioned mathematical operations for calculating the circumference and area of large objects like Jambudvip, etc. We find mathematical operations not only in the Jambudvip Pragnapti, Surya Pragnapti, Chandra Pragnapti, and Dvipsagar Pragnapti, but also in other agamas as well, like Bhagavati Sutra and Anurogdwa Sutra also. Next slide, please. In Jambudvip Pragnapti, in the editorial notes, Acharya Munisandra Suriji has clearly mentioned that pious leadership of Devadikani et al. When all agamas were written in on the palm leaf, the original scriptures would have been shortened because with time a large portion of the original scriptures would have been lost or forgotten. And this lost portion would have been substituted from the Jivabhigam by Upadhyay Shanti Chandra. In such a way, large portion of the original scriptures was lost during the oral traditions before the 454 AD, before Devadikanik Samasraman. Next, please. Next slide, please. Here is the statistical data regarding the mathematical operations. Egam joyena sahasram, ayamam vikhavenam, tinni joyena sahasrayam, sola sahasrayam, donya sattavishay joyena say. Yo is 3 lakhs 1600 227 yojana. Tinniya kose, 3 kosa, 28 धनुषयम 180 धनुष्य 1300 अंगुलायम अर्धंगुलम किंचित अधिकम 13.5 अंगुल किंचित विशेषाधिक परिखेवेन पन्नतम. In this verse, author has mentioned the circumference of a jambudvip. They have also given procedure to calculate the square root of 10 lakh crore for the circumference of jambudvip. To calculate the area of jambudvip, they mention that the circumference should be multiplied with a fourth of the diameter or the half of the radius of jambudvip, which is as follows. Vikhamba Vaggadogna Karni Vattasta Padiravo Hoi Vikhamba Paya Gunyo Padiravo Tasta Ganepayam. Here Padiravo means circumference. Ganepayam means area. Vikhamba means diameter. Karni means square root. And Vattasta means regarding the specific circle. There is also a procedure to calculate different types of arcs, chap of circle objects like jambudvip. They widely use the root 10 instead of geometrical figure 5. Next, please. A conference of well-versed scholars and prominent Jain Acharya was held in 1300 BC at Patliputra, modern Patna, presided over by Arya Sulibhadra, who was the chief disciple of Arya Bhadrabahu, who was the sixth Arya Acharya in the lineage of Lord Mahavir, and who is held in high respect by all sects of Jainas. He was called as a Sutakevali. For the same reason, second conference was held in the 1300 AD at two places, simultaneously at Mathura, presided over by Acharya Skandil, and at the Valvi, presided over by Nagarjun. But the oral tradition continued. Then again, for the same reason, a third and last conference was summoned by Devadiganik Samasaman at Valvi in 1454. Next slide, please. There is no clear evidence of zero in written form in Anuyogdva Sutra and the Bhagavati Sutra at the time of compiling the Agamas in 454 AD. The word Sunya was used for zero. Of course, the word zero was not given to Sunya at that time, but it doesn't mean that in ancient Jain scriptures there was no references regarding zero. In Anuyogdva Sutra, as Professor R.S. Shah mentioned that Anuyogdva Sutra, there is a reference of highest human number, which is equal to 2 raised to 32 multiplied by 2 raised to 64, that is equal to 2 raised to 96. There are 29 digits in this figure, which are as follows. And here, the last fourth digit is 0, which is indirect proof of 0. And this is the indirectly mentioned in Anuyogdva Sutra, which is quoted by Professor R.S. Shah in his early lecture. Next slide, please. In the second chapter of Jambudvip Pragnapti, the Sutrakam and the commentator both have given statistically largest possible figure mentioned in two systems. One is the decimal system and second is on the basis of 84 lakhs. This largest figure is named as the Sridhara Prahelika, and according to Mathuri Vatna, it contains 194 digits, while according to Valvi Vatna, it contains 250 digits. In these two versions of Sridhara Prahelika, there is a in the first version, there are 54 digits, different 44 digits, followed by 140 zeros. While in second version, there are 70 different digits followed by 180 zeros. Both figures are as follows. In these figures, you can see there are use of zero. So prior to Aryabhat, zero is mentioned in this Srisha Prahelika digits. Next, please. Here, the manuscript of Jambudvip Pragnapti, which is written in 1600, Vikram Sambat 1663. And in this manuscript, you can see both the figures of the Srisha Prahelika with the mentioning the zero. In this way, Srisha Prahelika contains also zero, which is prior to the Aryabhatta. Next, please. Thus, in the Jain tradition, zero is used prior to Aryabhat and Baksali manuscript. But unfortunately, we haven't any scriptural proof for this. But according to tradition, what we have at present in manuscript form are not new. They were originally copied from former manuscripts. And finally, or ultimately, it was orally asked by Jambu Swami or Sudharma Swami. And they got this information from Lord Mahavir. And in this way, this information about the Sri Prahelika came to us. Next, please. According to the Jain tradition, mentioned in many more ancient Jain canonical scriptures, mathematics had been taught by Lord Mahavir to Sundari. Now we have to discuss how the symbol of zero was formed. Zero is a unique gift of Indian mathematicians to the world. Of course, who invented zero? How? All this cannot be definitely decided, but we can make inference. Generally, most scholars believe that zero was invented in India by Aryabhat. Albeit, no doubt, zero was invented in India, but not by Aryabhat. Zero was not invented by a single person. It was invented gradually with time. Next, please. Here, at present, we make the dual use of zero as a symbol and as a number. In the initial stage, zero was used as a symbol for total absence of an object. Formerly, Indian writers used the words and letters to indicate the numbers and figures. In ancient period, almost all treatises on mathematics as well as literature on other subjects were written in Sanskrit verses. That is why the letters of the alphabet or symbolic words were used in Sanskrit, or the words were directly used for the numbers, namely 1, 2, 3, etc., are mentioned in the verses. Here, in this verse, Gopi Bhagya Madhuata Sringi Soda Di Sandiga Khala Jivita Khatava Galahala Rasandhala. This is a Sanskrit verse which there is a praise of Lord Krishna and also the value of pi up to the 31 digits after the decimal point. It was correctly mentioned in this verse. It is in this way words and letters are used in the Sanskrit literature. Next. The words sun, moon, Brahma, and earth, etc. words were used for one. Eyes, ear, nose, hands, legs, feet were used for two. tenses, world, gun, sandhya were used for 3. Similarly, various words were used for 4, 5, 6, 7, 8, 9, 11, 14, 15, etc. 0 was represented by the sky and its different synonyms. According to the rule Ankanam Vamato Gatihi, the number 1230 could be shown in the words using the words Kha, Gun, Netra, Surya. As for example, the stanza in the colophon of Oriental scriptures entitled Putraida were written in the second half of the 11th century AD as follows. Anhilla Pataka Nagare, Dohatti Sesha Satka Vasataucha, Santistata Kritayam, Navakara Hara, Vatsade Chaiva. Here, Navakara Hara, writing the manuscript is shown by the words Nava, Kara, Hara, 1129 Vikram Samvat is mentioned in this verse. Samvat, Panchadase Dvipancha, Ganite Varse Harsha Prade, Sutri Ahmedabad Namni Nagare, Deepotsave Nirmita, Yavat Sri Jina Sasanam Vidayate Sarvotsavai Sarvata, Stavan Nandatu Vrittika Kavijane, Vavachyamanasana. Here the words Panchadase and Dvipanch are directly used to mention the writing year of the another manuscript of Uttarayana and Sutra and its commentary. In this way, the Sanskrit words and letters are used for the figures of the year of the writing or composing year. Next slide, please. As in the set theory, George, as we know that George Cantor is the originator set theory. He has mentioned set theory, but this set theory has been more ancient than George Cantor. As in the set theory, members of each set are denoted in the brackets like Surya, Graha, Guna, Samudra, etc. But when there is total absence of the thing or the member in a set, a point was put between the brackets along with the sky, Kha, and it was the proof that in initial computers in DOS system there was a dot in 0. Here the picture has been given that 0 is mentioned with the point in the center of circle. Next, please. Yet at present, simple brackets are not used for the mentioned null set, but curly brackets are used. This null set or empty set is also denoted by the sign sigma. Null set denotes the total absence of a thing. As the time passed by, the point dropped out of the bracket and only brackets were used. The people who wrote the symbol of brackets hurriedly, they perhaps joined the brackets together, and this is how today's form is of 0 came into existence. It is my inference that 0 was thus created, and you can see the letter O of English alphabet is completely round, while the 0 is not completely round, but it is oval shape. It means it is formed with the bracket. So it is a wrong belief that 0 was invented by Aryabhat. As I have shown, 0 was not even invented by single person. It was gradually invented by time. Next slide, please. And that is the end of the presentation. So it is my inference that Zero is invented by gradually. Thank you very much.
Shri Nandigosh Guruji Maharaj, thank you so much. We are deeply privileged and honored to have you present. Also, I think you present a very strong case of zero, and the fact that you're also on the committee, which is looking at the ancient scriptures, the Research Institute of Scientific Secrets from Indian Oriental scriptures, is truly profound, and you are a great asset to the study of Jain mathematics. So thank you so much. It's fascinating, is what I'm hearing from Mr. Manish Mehta on the chat as well. So there may be some questions I also see by Nirmala Shah and Jayanta Acharya. I would like to hold them up, and let's move to our next presentation. And that will be by Dr. Kanti Mardia and Dr. Anthony Ruda on some aspects of Jain logic and statistical thinking. So I would ask Dr. Kanti Mardia and Dr. Anthony Ruda for their next presentation.
Hello, can you hear me?
Yes, we can.
Thank you. So hi, my name is Anthony Ruda, and on behalf of my collaborator, Professor Kanti Mardia, and myself, I would like to thank the organizers of this symposium for the opportunity to present to you today on some aspects of Jain logic and statistical thinking. If I may offer one correction, I do not in fact hold an advanced degree, so I cannot claim to be a doctor, although I did study mathematics as an undergraduate. Thank you. Next slide, please. So by way of background and overview, Jain logic is one of the important areas of Jain philosophy and mathematics, in which some aspects are well studied in modern terminology. For example, the conditional predication principle Syadvad has been interpreted in relation to statistics, Boolean algebra, and quantum theory, but still some areas are not yet touched. So we examined the Jain syllogism Pancha Vayavavakya, one of the areas of Jain logic that has not been thoroughly studied in modern scholarship. And here I must confess that I am not quite the scholar that Professor Mardia is, so I ask for your forgiveness for my pronunciation of the ancient terminology, although I will try my best. So we discussed the 5 components of the Jain syllogism: Pratishna, Hetu, Udaharanam, Upanaya, and Nigamanam in depth, and show how the Jain syllogism matches the basis of the current statistical inference. Specifically, when Syadvad combines with Pancha Vayavavakya, we are in the realm of the Bayesian approach. We also introduce a formal notation to summarize Syadvad and better illustrate the modern mathematical connections. And lastly, another aspect of Jain logic is the holistic principle on Ekantvad, which we show, as in the parable of the blind man and the elephant, has as its corollary a stratified sampling. Next slide, please. So starting off with a cultural comparison before reviewing the Jain syllogism, we begin by noting the familiar Aristotelian syllogism, which consists of 3 components: the combination of a major premise and a minor premise from which a conclusion is deduced. The classic example is major premise, all men are mortal; minor premise, John is a man; conclusion, therefore John is mortal. And of course, the traditional formulation mentions Socrates, which we have substituted with John for reasons that will become clear shortly. Next slide, please. So as detailed in the Tark Sangraha of Anambat, the Jain syllogism consists of 5 components: Pratijna, or proposition; Hetu, or reason; Udaharanam, or example; Upanaya, or application; and Nigamanam, or conclusion. Next slide, please. A specific example of the Jain syllogism in the Tark Sangraha relates to fire on a mountain. So we analyze its 5 components in English translation as follows. Proposition, there is a fire on the mountain, which is the proposition hypothesis to be proved. Reason, because there is smoke on the mountain, which is the reason, cause, or evidence for the hypothesis as the indication of the basis of the conclusion. Example, where there is smoke, there must be fire, as seen in the kitchen. This is the example establishing the general rule, as the kitchen is symbolic of all places where there is fire. Application, the mountain is smoky, which is the application of the rule as the basis of the argument. And the conclusion, therefore there is a fire on the mountain, which is the conclusion as fire and smoke are both observed to exist as cause and effect. Next slide, please. To take a more modern example, the 5 components are proposition, John will die, reason, because he is a man, example like Tom, Dick, and Harry, application as they died, conclusion, therefore John will die. And this syllogism was rearranged by J.L. Jain to reveal the connection to the Aristotelian syllogism. Tom died, Dick died, and so did Harry. Tom, Dick, and Harry are truly universal types of men. Therefore, all men die. John is a man. Therefore, John will die. And in this way, we can see that the last 3 terms in this arrangement correspond to the major premise, minor premise, and conclusion of the Aristotelian syllogism. All men are mortal. John is a man. Therefore, John is mortal. Next slide, please. Now, in contrast to the 3-fold Aristotelian syllogism, the 5-fold Jain syllogism, in fact, has its origins in a 10-fold syllogism from earlier stages of Jain thought. As detailed by Bhadra Bahu and translated into English by Bhattacharya, the 10 components are proposition, limitation of the proposition, reason, limitation of the reason, counter-proposition, opposition to the counter-proposition, example, validity of the example, meaning of the question, and conclusion. And we can see where the components of the 5-fold syllogism remain in parallel to the earlier form with the bolded terms on this slide. And notably, hetu or reason was ascribed greater significance by later logicians such as Hemachandra, eventually becoming the middle term in the 5-fold syllogism. Next slide, please. Now, the Jain syllogism can be viewed in Bayesian terms with a slight modification to the modern example when we combine it with syat of syadvad, which we will examine more closely shortly. But for the time being, we translate syat as meaning maybe. The first component, Tom died, Dick died, and so did Harry, offers data. The second, maybe Tom, Dick, and Harry are universal types of men, establishes prior probability, while the third, maybe all men die, would be the posterior probability. The fourth component, John is a man, can be taken as a new observation, and following this thread, we may arrive at the prediction probability in the 5th component that maybe John will die. Next slide, please. And we can further analyze this example both qualitatively by means of the flowchart at left and quantitatively by means of Bayes' theorem at right. So we've already seen the connection between the 5-fold Jain syllogism and the Aristotelian syllogism. Its 3 terms can be generalized to the form all mortals die, all men are mortal, therefore all men die, which can be abstracted to the form all M are P, all S are M, all S are P, where M equals middle, S equals subject, and P equals the predicate terms of the argument. So taking the data of the deaths of Tom, Dick, and Harry, and the new observation that John also is a man, we arrive at the prediction that John will die. And if we let event A be the death of John and event B be the deaths of Tom, Dick, and Harry, we can find the probability that John will die given that Tom, Dick, and Harry died by following Bayes' theorem. The probability of A given B, which is the posterior probability, equals the probability of B given A, or the likelihood of B being true given that A is true, times the probability of A, which is the prior probability, over the probability of B, which is the marginal probability or the overall probability unconditional of any event. Next slide, please. And having earlier introduced the term syat, we now review the conditional predication principle of syadvad, which examines inference from 7 standpoints, each prefixed by syat, which we will translate now as from one standpoint rather than as maybe. So from one standpoint, it is, from another, it is not, from another, it is and is not, from another, it is indeterminate, from yet another, it is and is indeterminate, from another, it is not and is indeterminate, and it is not, and is indeterminate. Next slide, please. A formal notation becomes useful for summarizing the concept before we illustrate the modern mathematical connections. My collaborator, Professor Mardya, in his 1990 book, The Scientific Foundations of Jainism, introduced the following notation. plus for it is, minus for it is not, plus minus for it is and is not, the question mark for it is indeterminate, plus question mark for it is and is indeterminate, minus question mark for it is and it is not and is indeterminate, and finally the plus minus question mark for it is not, and is indeterminate. Now, while there has not been any difficulty in assigning plus to preposition 1 and minus to preposition 2, the key breakthrough from Mardia 1990 is the question mark notation for preposition 4. Some antecedents can be found in the work of Motilal 1981, who used 0 for preposition 4, but this doesn't quite accurately reflect the concept. And we refer you to our paper on this topic for a fuller discussion around this. An alternative is found in Haldane 1957, who used 1, 0, and the Sanskrit symbol mra for prepositions 1, 2, and 4 respectively to indicate the 7 standpoints. However, Haldane was connecting the conditional predication principle with finite arithmetic and computer architecture when he used mra for preposition 4. Preposition 4 could otherwise be viewed in mathematical terms as akin to 0 over 0, but the question mark is like seeing the yellow light at a traffic signal where there is ambiguity. Next slide, please. So following Professor Mardia's notation, Syadvad can be visualized as a Venn diagram. The 3 main prepositions 1, plus, 2, minus, and 4 question mark can be viewed as events A, B, and C respectively, while the others are viewed as the intersections of these events. Next slide, please. And finally, we turn our attention to the core concept of Jain logic, anekantvad, which is traditionally described by Jain logicians through the parable of 6 blind men who want to know what kind of object an elephant is. Each touches a different part of the elephant. The one who touches a leg says it is a pillar. The one who touches the tusk says it is a pipe. The one who touches an ear says this is a winnowing fan, and so on. Thus, each perspective differs, offering only a partial viewpoint, and so if we wish to understand what kind of object an elephant is, we must look at it from all sides. In this way, we can see that the conditional predications of Syadvad applied to each entity are like beads held together by the holistic principle anekantvad behaving like a thread. And as this example applies, there is an art to sampling and interpretation that on the one hand reduces complex information to useful data through stratified sampling, and on the other delivers a recognizable approximation to truth. We note that in this example, the sampling is stratified but not totally random, as the 6 blind men are looking at different parts. Next slide, please. So in conclusion, by providing a comprehensive review of the Jain syllogism, we have unified the literature and brought the concept in line with modern mathematical terminology. And we refer you to our main research paper for a full list of original sources. We have also shown how Jain logic foreshadowed and figures into some areas of modern statistics, and how combining the Jain syllogism with Syadvad by adding Syat to the Jain syllogism results in a Bayesian approach. And by using Venn diagrams and advancing a plausible notation for the Syadvad system, we have also made these Jain ideas more accessible by presenting this ancient concept within the terminology of modern logic. As a final note, although we have not touched on it today, our main paper also includes connections to the work of Turing and Gödel. This concludes our presentation, and we thank you for listening.
Thank you so much, Mr. Anthony Ruda. And with these presentations, actually, I think you deserve a Dr. Anthony Ruda as well. So wonderful, wonderful presentation. You know, in syllogism, I always thought of, you know, A equals B, B equals C, and so A equals C as the depth of it. And your work and Dr. Mardia's work really has taken a new light for me to be able to understand this, especially having known and having some background knowledge of Anekantvad and Syadvad, and explaining the stories and the depth by which you're able to take these ideas, and our Jain scholars, ancient scholars had them as well. So very delighted for your presentation. And Dr. Mardia, I see that you're also there. If you'd like to add anything more, we would be delighted. Your comments, please.
Well, I just want to say that this conference is really a breakthrough If you could hear me, can you hear me?
Yes, we can hear you. Thank you so much.
Yes, it is a real breakthrough because it was needed and a great initiative taken by Pankaj Bhai and others, organizer, to bring it, for general, as if we are in public domain. The one thing which is what Anthony has tried to do, and one thing which is I am more interested in throughout my Jain career as a fair. That's my second horse. So the main horse is statistics. But the main has been, it is very important. I must not undermine that historical data mining is crucial. One has to see who invented zero, what was the background, who invented set theory, all these related to modern concept. But I think the question is it going to help new mathematics in any way, in the modern mathematics? And this is one example where there is some meeting of two minds that to take it forward. I think because acharyas were eminent scholars, they created new terminology, new system, and they were all Gyani. I'm not Gyani at all. I'm just a simple, statistician, stroke Jain scholar. But they were all these Gyani. What they did, they took the subject forward. It is not just going to history, finding scriptures, which is very, very important. Don't misunderstand me. But mine would be more on how to connect and take it further. I think the great ideas are all there, but what it is adding to the current knowledge of mathematics, I think that's one of the challenge for all of us. And of course, this is the conference is doing wonderful job because they are both. It is a marriage between. I think one side is historical data mining, which is what I call, which is very important and crucial for people to know what Jain thinkers are or where. But other is to extend it, that what they did can be applied further and can be applicable to the evolution of modern mathematics. That's all I want to say with all due respect. They're all Gyani here and I'm just a layperson just speaking.
But you have done a great job, Dr. Mardia, and certainly Anthony and all. We are really pleased, and you're exactly right that is the objective for us, to mine the past and then polish our ancient scriptures, the jewels that are there, and then to bring them to light so that we can benefit from them and advance our knowledge. And that is the purpose of our conversation. And yes, it is a landmark event that we are meeting. And in the future, we will be meeting in person. Institutions such as MIT will be hosting us. They were not able to host us because of the pandemic. So yes, very much so. I would like to go on next to our next presentation. And we have two more presentations for this evening or this morning. And this one is by Dr. Anupam Yash from the ancient Jain mathematics thought, the logic of Saptabhandya. So Dr. Anupam Yash, can you hear us?
Hello.
Yes, go ahead, sir.
Am I audible?
Yes.
Jai Jinendra.
Jinendra, can you open your video, please?
Here with,
yeah, we can hear you.
I was spotlighted him now.
Yes,
but his video continue. Is not on. It's okay.
Okay, your video cameras, if you can turn on.
Yeah, thank you very much.
Okay. Today I am going to talk about ancient Jain mathematical thought, the logic of Saptabhandya. My topic is very elaborative, and here I have to discuss only a few points for the time constraints.
I think we're losing your audio. Dr. Anupam, can you hear us?
Am I audible, sir?
Yeah, now you're audible. Go ahead,
Hello.
continue, please. Yeah, please continue.
How? Though mathematicians have no religion or sect, Jaina mathematics, one might say, does exist in two separate spheres. Next slide, please. One in Jaina cosmography and cosmology, and the others is in Jain logic. Jain cosmography deals with time and space, eras and sizes of the various worlds, number of high magnitude, distance between the continent of worlds, and Jain cosmography might go up in arithmetic, geometric, or in some other progression. The second one, Jaina logic, deals with Jaina epistemological view of Saptabhangi Noyo. In Saptabhangi Noyo, the Jaina logicians
We may be losing your bandwidth and losing you because of the bandwidth. So you may want to turn your video off and continue with just the audio.
in Saptabhangi
If you
are trying to develop. Am I audible, sir?
You are, but you're going in and out, so you may just turn off your video. So that might work better. Yeah. Go ahead.
Which it has, and each of which is separately grasped by other statements. In modern Western logic, there are some new branches of logic, namely the many-valued logic, modal logic, logic of conditionality, and logic of existential quantification. In this paper, I intend to examine the different interpretations of Saptabhangi Noyo given in terms of modern Western logic by S.L. Pandey in terms of many-valued logic, M.P. Marathe in terms of modal logic, B.K. Motilal in terms of logic of conditionality, and Pradeep P. Gokhale in terms of existential quantification. But none of these interpretations, I have argued, is satisfactory. I have given my own interpretation of Saptabhangi Noyo using existential quantification that avoids the inadequacies of Gokhale's interpretation and preserves the basic idea of Saptabhangi Noyo. S.L. Pandey, in his paper Neubad and Many-Valued Logic, tries to assimilate the logic of Noyos with Lukasiewiczian three-valued logic by exploiting the distinction between Pramano, Noyo, and Durnoyo, following the interpretation given by Jaina philosopher Acharya Mallisena. Next slide. According to Sadvad Banjari, a Pramano is true and a Durnoyo is false. Consequently, the truth value of a Noyo is different from the true and the false and is, properly speaking, indeterminate or a third logical value. According to Pandey, this concept of the indeterminate truth value perfectly accords with the similar concept of Lukasiewicz concept of indeterminate truth value. This question is extremely relevant on the consideration of following grounds. First argument, Jaina logician regards a Noyo neither as Pramano, true statement, nor as Apramano or false statement, but as approximation to Pramano. So the Jaina concept of the truth value of Noyo is logically the same as Lukasiewicz's concept of the indeterminate truth value. Second argument, but both Acharya Akalanka and Acharya Vidyananda have a clear conception of probability. Acharya Vidyananda says, while commenting upon the Ashtaswati of Acharya Akalanka, that Pramanno or logical value of every Noyo is a probability value or a position involving both truth and falsehood in various degrees, and hence Noyobado leads to a non-truth functional many-valued logic of probability. Third argument of Pandey, Mollabardin in his Dadosara Naya Chakra has designated the three original Nayas as Bidhi, Bidhi Niyamo, and Niyamo. What is remarkable in this conception of Mollabardin is that he clearly conceived the three truth values and classified statements according to their truth values. Next slide, please. Fourth argument. Jaina logicians have displayed these three truth functional operatives, namely negation, disjunction, and conjunction. Again, suppose a statement P has the truth value I or indeterminate. Now, all the statement of Naya Saptabhangi respectively has the truth value I. So the table of 7 Nayas is like this. Next slide, please. Now, a critical estimate of Pandey's interpretation. In next slide. First, Pandey's main contention stated as the first ground is that the Nayas fall between the true and the false. Therefore, they have a type of truth value which is logically the same as Lukasiewicz' indeterminate truth value. It may be pointed out that Lukasiewicz does not regard the indeterminate truth value.
Lost him again.
We might be losing you again, Dr. Josh. We will wait and see if.
On this contention, every Noyo is a probability value in various degrees, but these claims are also false. We may point out that the probability of a statement is always relative to the evidence produced, and the probability is calculated on the basis of this evidence. Again, every probability statements are correct or true. Third, as a third reason in support of his view, Pandey refers to Mollabardin, who, according to Pandey, has designated the three Nayas of the Jaina, Bidhi, Bidhi Niyamo, and Niyamo, as original. But a reading on Mollabardin's Dadosara Naya Chakra reveals no such three Nayas as original. If we regard the Nayas as original, on Mollabardin's view, they could be Bidhi and Niyamo. The other Nayas would be arise out of the combination and repetitions of these two.
We might be losing you again. So we go to the next slide.
Now we come to discuss modal logic and Saptabhangi Naya. Next slide. Modal logic is a logic that contains modal operators. Modal logic work with two modal operators which attach to whole propositions. When you say of any propositions P that it is possible that P, we are applying the modal operator MP, and it is necessary that P by LP. We may consider an interpretation of Saptabhangi Naya given by S.S. Barlinge and M.P. Marathe that applies the model concept of possibility for an understanding of Shat. Gokhale formalized the sevenfold scheme according to modal logic is as follows. The justification of this formulation may be given on the face of it by bringing in the Jaina concept of Naya and the third truth value, the indeterminate, and by linking the indeterminate, so possibly. One may argue that all the Nayas being expressions of partial truth are indeterminate, and possibly P or MP is taken to be indeterminate and have the third truth.
We have we've lost the connection again. We'll wait for just a little bit and see.
Hello.
Dr. Josh, can you hear us?
Hello.
Yeah.
Hi. Hi. Am I audible, sir?
Yeah, again, please.
Again, it does not seem right to equate or identify partial truth with indeterminateness. A noyo expresses a partial truth, which means that it is true in in certain respect and certainly true in that respect. Truth or falsehood of noyo does not imply any kind of uncertainty, whereas indeterminateness does involve a kind of uncertainty. It seems to us that to make any modal interpretation of Saptabhangi noyo inappropriate and so cannot be accepted as logically justified. We shall now consider yet another attempt to interpret Saptabhangi in terms of conditional logic made by Bimal Krishna Motilal, whose conditionality
We've lost him again, but we can read the slides as they're there, and we'll just wait for a moment for him to join in.
Slide 7, please.
Yeah.
Slide 7, please. Slide 7, please. Hello.
Yes, please go ahead.
Okay. Bimal Krishna Motilal's conditionality approach to Shat statement involves the use of truth functional propositional logic and the logic of quantification. According to Motilal, the Shat particle prefixed to a categorical proposition converts it into a conditional proposition. He takes, for instance, the categorical proposition A is F, where A stands for a particular thing, say the self, and F stands for a certain property or quality, say eternal. It's a previous slide, sir. To say Shat, if A is F on its interpretation, is to say that one, if P, then A is F, where P is supposed to express in a certain sense yes. In the similar way, Shat A is non-F turns into 2 if Q, then A is non-F, where Q is supposed to express in another certain sense yes. These two conditional propositions represent, on Motilal's view, the first two indications of in the sevenfold scheme. According to him, these twofold conditional proposition can be more fully expressed in the following way. For all x, if x is considered from the standpoint 1, x is eternal.
We've just lost connection again. Dr. Jesh, we will wait. Can you hear us?
Yes, sir.
Okay,
Let
please
us
continue.
look at Motilal's interpretation of Shat predication as conditional proposition more closely. We know that a truth functional conditional proposition can be true even when the antecedent is false and the consequent is true. What we want to stress here is that if Motilal's interpretation were right, its consequences would be devastating for the Jaina philosophy as a whole. It is possible for the antecedent of 1 to be false and the consequent to be true. In that case, A is F without regard to the truth of P, which simply means that A is F is true. Without regard to any Shat particle, it means absolutely true. Similarly, it is possible for all substitution instances of the antecedent of 3.
I think we've lost connection. Just Dr. Jesh, maybe the connection is very intermittent, so you could maybe finish off in a few minutes. The connection is very poor.
Very poor.
Yeah. Just go if you can finish off in the next 3 to 5 minutes.
Next, okay. Next slide number 9, please. Pradeep Gokhale, in his article, The Logical Structure of Shadbado, gives an alternative formalization of the Saptabhangi. This model we may call the model of existential quantifier. Gokhale tries to analyze the Shat statement, Shat Jiva Nityaha. There is a standpoint such that self is permanent is the case. Gokhale says, if x is introduced as a variable ranging over different standpoints and p as a constant, which stands for the statement self is permanent, then the statement self is permanent would mean b, there exists some x such that x makes p true. Gokhale now state this formalization of the sevenfold scheme involving the statement P as follows in the screen. Next slide, please. Now, a critical estimate of Pradeep Gokhale's interpretation. There are certain grave objection to Gokhale's formalization. First, P is symbol for permanent, but permanent is predicate term, and it has to be treated as such the quantification theory. A predicate is unsuitable as a term in a relation. Gokhale puts in a predicate term permanent to retain its predicative function in a way what is not permissible. Secondly, Gokhale has to spell out what relation does F stands for. What is its predicative function? Gokhale slips in permanent as a term in the relation F. In C, there is at least one x sx dot f sxp to get the predicative function done by P doing duty for permanent and leaves F high and dry. It shifts, therefore, Gokhale's translation of B, there is a
Oh, we've just lost you for a bit there. We'll wait for a few minutes. Yes, go ahead.
Finish my.
Yeah, go ahead.
Or two slide. Slide 11. Slide 11. We may now proceed to give formulation in terms of this model of existential quantification of the sevenfold predication of the Jainas. These formulations are stated as in the screen. In the above formalization, we have used the the connective dot in a circle to capture the meaning of kromobhavo or successiveness. When two statements are made one after another, both are made but successively so that the kromobhavo or serial order cannot be turned around. For this reason, we have used different symbols.
We've lost you again. I apologize to everyone. The internet connection is bad.
Dot the circle. The symbol dot in the circle is different from dot or and because it carries the meaning of and but also the sense of order. So it is proper to use a different connective to indicate kromobhavo. Now, next slide, conclusion. Previously, we have seen that various critics from different systems of philosophy have discovered logical flaws in the Jaina Saptabhangi Naya. In this paper, attempt has been made to establish the theory on a very solid logical foundation. It is true that several attempts have been made by different modern scholars to justify Saptabhangi Naya from a logical point of view, but these attempts, in our opinion, failed. Consequently, I have tried to provide a logical explanation as an alternative to what have been proposed earlier. It has been found that it is possible to justify Saptabhangi Naya from a logical point of view. With this logical foundation, Jainism in this aspect stands as an original contribution to the philosophic literature of India. Thank you for your attention.
Thank you, Dr. Anupam Jash, and excellent presentation. You bring to surface from a philosophical perspective what we heard from Dr. Kanti Mardia and Mr. Anthony Ruda on the statistical perspective of looking at Syadvad and the Jain logic with great reference to the Saptabhangi Naya scriptures. This truly is a a marriage of Jain mathematics and Jainism and mathematics together, as well as bringing these concepts from multiple perspectives. So for our last presentation for today, I would like to ask Dr. Jitendra Sharma and Dr. Anupam Jain to talk about the concept of infinites in Jaina literature. And if we have time, we will entertain some dialogue and questions after that from all of our speakers. And please present your questions on either the Q&A or the chat that's there, and we'll try to address as many as possible. So Dr. Jitendra Sharma.
Yes, good morning to all the panelists and good evening to all the panelists as well as the participants. I'm going to, am I audible to all?
Yes, thank you so much.
Yeah, okay, thank you, sir. So I have made some attempt to elaborate the concepts of the infinities as described in the Jaina literature. So first of all, I want to say that in Vedic literature, God is considered as Anant. So Anant is a Sanskrit term which means endless, means which is not having any end, or we can say the limitless, or we can use the word eternal also, or we can say infinite. So in other words, it also means the infinitude or an unending expansion or without the limit. So next slide, please, sir. So here you can go through the short abstract is there. So in the present article, I have elaborated the different classifications of the numbers according to the Jain theory. And for this purpose, we have used two texts. One is Dhawla commentary, and the second one is the Loksar of Nemichandra Siddhant Chakravarti. So Nemichandra also given have provided some infinite series. So we'll discuss about the classification of numbers, classification of infinities, and the infinite series in short. Next slide, sir. Next slide, please. Okay, so the concept of zero and infinity is very significant in mathematics. Zero represents the non-existence, while infinity is endless. In Vedas, God is considered as infinite, as I told earlier. The infinite again must be one, otherwise it is finite. If there be any other thing beside that infinite, then it is no longer infinite. It is limited by that object. Consequently, it has become finite. Infinity is the idea of something that has no end. Philosophers speculated about the nature of the infinity. In mathematics, infinity arises in two places. First, in the counting numbers, and in geometry. In context to the counting numbers, it's always possible to add one more. Thus, there is no greatest natural number, and the collection of natural number is infinite. While in geometry, a line can be indefinitely subdivided. However, for the process of subdivision has gone further, division is possible. Infinity is a goal which cannot never be reached. It is universally accepted.
Can you increase the volume? Can you speak a little loudly, please?
Okay, sir. Okay.
My request to the scholar, please speak loudly. Thank you.
It is universally accepted that the concept of infinity is the original contribution of ancient Indian mathematicians, which have played a very vital role for the development of concept of infinity. There is yet another facet of the idea of infinity, namely the counting infinity. In modern mathematics, this leads to the concept of ordinal and the cardinal number. Actually, Brahmagupta in 628 AD wrote the Brahma Spurt Siddhanta and attempted to give the rule of arithmetic involving zero. He explained the mathematical operations like addition, subtraction, multiplication involving zero, but when he tried
to division by 0, he gave some results. He tried to give some results, but the results were not correct. After 500 years of Brahmagupta, Bhaskaracharya tried to solve the problem of division by stating that any number divided by 0 is infinity. In 850 AD, Mahaviracharya wrote Ganita Sarasamgraha. He correctly stated the multiplication rules for 0, but fails to explain properly division by 0. In ancient mathematics, we find a Jaina text discussing various such concepts of infinities. In ancient Indian mathematics, we find Jaina texts discussing various such concepts of infinities. These texts are mainly religious or philosophical, but often carry a healthy amount of serious mathematics. This seems to introduce formal concept of infinity, innumerable, numerable, and infinite. They even classify multi-dimensional concept of infinity. It is possible that they might have come close to the ideas of modern cardinality as given by Cantor. Jaina mathematicians have calculated various quantities relating to living, non-living beings, geography, astronomy, etc. They were very passionate to know how much and how many in context of every existing object of the world, living and non-living. This classification of numbers is the uniqueness of the number theory of Jaina philosophy. The contemplation of such large number led the Jainas to an early concept of infinity, which, if not mathematically precise, was by no means simply minded. In the present paper, we'll discuss the texts of Virasena, that is Dhavla, of 816 AD, and the Triloksar of the Nimichandra, Siddhant Chakravarti, Triloksar of 10th century AD. So next slide, please, sir. Sir, please. Yeah. So here in the present slide, you can see the classification of number. In Jaina canon, enumeration goes to Shirsh Prahelika. The Shirsh Prahelika is the large number, can be represented mathematically as 84 raised to 28 multiplied by 10 raised to 140. Shirsh Prahelika is a number containing 194 digits. It's a huge number. In Anuyogdvar Sutra and the Bhagavati Sutra, there is significant remark that arithmetic ends here, and further enumeration can be understood through the simile measures, that is Palyupam, Sagrupam, like that. And Jain saints wanted to go beyond the Palyupam and Sagrupam. They classified all the numbers in 3 groups, and these numbers are Sankhyat, Asankhyat, and Ananta. Each of these again divided into 3 orders, considered as namely Jaganya, Madhyama, and Utkrisht. So in this way, we can have 3 types of innumerable. Then innumerable is Parita Sankhya, Yukta Sankhya, and Asankhya Sankhya. In infinity, we have 3 classifications like the Paritananta, Yuktananta, and the Anantananta. Moreover, each division of Asankhya and Ananta is further divided into 3 categories, which we have mentioned here. So this is the classification of number in 3 categories. Next slide, please. So in this chart, you can see the classification of the number. The main is Sankhya, Sankhya, Asankhya, and Ananta. Sankhya is divided into 3 parts. Then Asankhya, Parita, Yukta, Asankhya, and further the Parita Sankhya is divided into Jaganya, Madhyama, and Utkrisht. So in this way, Jainas has classified the numbers in 21 classes. You can see here the 9 types of Ananta is there, 9 types of Asankhya is there, and 3 types of Sankhya. So in all, 21 classes of numbers are given by, the classification was given by Jaina saints. Next slide, please, sir. Next slide, please. And here, in this chart, you can see the numbers, their meaning. The English term is used for this Jaganya Sankhya and Madhyama Sankhya, etc., and symbols which we have used in this work. So JS indicates the Jaganya Sankhya, and numerical value of this Jaganya Sankhya is 2. So here, interesting to know that in Jaina literature, the counting starts from 2. 1 shows the existence of anything, means 1 is not considered as the number, but it was considered as the existence of anything, any object. If it persists, then 1 is the representation of that existence, and the counting starts from 2. So Jaganya Sankhyaat, Madhyam Sankhyaat, 3 Sankhyaats are there, then Parita Sankhyaat is there. So you can go through this table. Then after that, so next slide, please. And then in Asankhyaat, we have Jaganya, Madhyam, and Utkrisht, then Parita, Ananta. So here you can see we are having 9 types of Ananta, from Jaganya Ananta to the Utkrisht Ananta. So this Jaganya Parita Ananta is considered as the minimum lower order infinity, represented by JPA, and the symbol we have used as beta in this particular work. Next slide, please, sir. Next slide, sir. Then after that, we are coming to the classification of infinity. The text Dhaula gives the classification of infinity. And according to this Dhaula, we have 11 types of infinity. While in the previous slide, we have discussed about the 9 types of Ananta Ananta. Okay. So here, according to the classification of infinity as per the Dhaula, the Namananta, Sthapananta, Dravyananta, Ganananta, Apradeshikananta, Ekananta, Ubhayananta, Vistarananta, Sarvananta, Bhavananta, and Sashvatananta. These are the 11 types of infinities described in the text Dhaula. Out of these 11, it is clearly mentioned that Ganitananta is considered as a mathematical infinity. So here we can you can understand that the 9 types of infinities which we have discussed in the last slides can be considered under this Ganananta. So here Gananantas are of 9 types. That is the mathematical infinity. Next slide, please, sir. Then very much discussion has been done by the Jain scholars about the Asankhyaat and the Ananta. So according to the studies, we can come to the we are coming to this point that according to all Jain texts, Jaganya Sankhyaat is the number 2. Unity was not counted as a member of the set of Sankhyaat, as I have mentioned. The Madhyam Sankhyaat includes all the numbers from 2, and Utkrishta Sankhyaat, which itself a number immediately preceding the Jaganya Parita Sankhyaat. In Triloksar, JPA is explained in the following manner. Here we have the representation for this particular thing. So next, please, sir. So according to Jain cosmology, the universe is composed of the alternate rings of lands and seas whose boundaries are concentric circles with increasing radii. The width of any ring, whether land or sea, is double that of the preceding ring. The innermost circle is called as the Jambudvip, with the diameter of 1 lakh yojan in diameter. Consider 4 cylindrical pits, 1 lakh yojan in diameter and 1000 yojans deep. Namely, the rings are named as A1, B1, C1, and D1. So these calculations are done by Professor R.S. Shah, and I have referred that particular paper, and Dr. Shah also mentioned about that paper in his lecture. So according to that, the calculations are mentioned here, and here N0 is considered, the value of N0 is considered calculated as V by V, where capital V is the volume of the pit and small v is the volume of the seed. So here N0 is calculated as 1.979 multiplied by 10 to the power 44. Later on, the value of N0 was determined by R.C. Gupta sir as 2.2265 multiplied by 10 to the power 4. And it was also observed by Dr. Shah that Nemichandra used some has committed some mistake during the calculation. Actually, he has used some different formula for the calculation of this value. So the difference was there. And still the number, and further, N1 is also calculated as the 10 to the power N0. So here we can see N0 itself is a number equal to 1.979 multiplied by 10 to the power 44, and here n1 is equal to 10 to the power n0. So n1 is quite large as compared to the n0. Further, we can have the value of n2 here. So n2 can be represented as 2 to the power 2 raised to 2 n1 multiplied by n1, and further it can be considered as equivalent to 10 to the 10 raised to 10 raised to 10 raised to 44. So still this number is very less than asankhya. As mentioned by Professor Shah, the value of minimum lower order enumerable is given by alpha, that can be obtained by adding the values of n0, n1, n2 up to n0. In the sum on the right side, each term is infinitely small, then its successor term. So it can be ignored, and the alpha, where alpha is considered as the sankhyat, Jaganya Parita Sankhyat. So the value of alpha can be considered as n0 raised to power 4. Next slide, please. Next slide, please, sir. And Dhaula categorically states that a sankhyat is a finite number which is exhausted by continuous subtraction of one after one. A sankhyat literally means innumerable and can be visualized as finite number that is not considered in number naming scheme. It could be a number which is outside the scope of elementary cognitive sphere, in the sense that it cannot be expressed numerically. Nemichandra defined a sankhyat as a number equal to 10 raised to 140. In Dhaula, a treatise on enumeration of souls states that the number which does not get exhausted by continuous subtraction of one after one is called ananta. Further, Dhaula states that the number which is not exhausted by continuous subtraction of even till the endless time has been called ananta by great teachers. Thus, ananta is a transfinite number, but such a clarity does not exist about the asankhyaat. Now, Jyoti Singh is in his article pointed about the confusion regarding the finitude and infinitude of asankhyaat. As per his findings, asankhyaat signified infinity only the asankhyaat pradesh, and asankhyaat kalan would mean actual physical infinity and hence provide a consistent cosmological picture. It could be the Jainas, from cosmological viewpoint, had a physical notion of actual infinity, but from mathematical point, they did not have such a notion of asankhya. Next slide, please. Next slide, please. Moreover, even in Dhaula, where finitude of asankhyaat is categorically stated, similarity of various meanings of the two classes of numbers is also discussed. Identical 11-fold classification of various meanings of ananta and asankhyaat is made in Dhaula. Among 11 kinds of meaning, the comparison of apradeshika ananta and apradeshika sankhyat gives interesting results. Apradeshik ananta refers to one parmanu of Pudgal, material indivisible monad, and Pradeshik Sankhyat refers to Pradesha of soul. Here, both Ananta and Asankhyaat denote the concept of actual infinity. Out of the 11-fold classification, only Ganana is open to numeration and to possible meaning of mathematical actual infinity. Apart from this classification, identical 9-fold division of Ananta and Asankhyaat is also given in Dhaula. Thus, only on the basis of parallelism between these two, we cannot consider asankhyaat as transfinite number or mathematical actual infinity. Now, Jyoti Singh has done the remarkable work, and he discarded the argument of A.N. Singh that Ananta Pradesha of Pudgal or Ananta Pradesha of Alokakash are transfinite number, but Asankhyaat Pradesh of Alokakash or Sankhyat Pradesh of a soul are not transfinite. In his article, he demonstrated that asankhyaat and ananta were used in sense of transfinite numbers in Jaina literature. Next slide, please, sir. Here, now we are coming to the the infinite series given by Nemichandra Siddhanta Chakravarti. So Nemichandra is one of the eminent scholars of Jaina philosophy. He also developed some interesting results of the number theory, as some other presenters also discussed about these types of series. So number theory in the form of 14 infinite sequences was given by by Nemichandra Siddhanta Chakravarti. He considered a main set, a main sequence that is considered as the set of natural numbers starting from 1 to infinity. So in the present table, you can see 14 types of series are there from Sarvadhara, as Sarvadhara, Samadhara, Vishamdhara, Kratidhara, Akratidhara, Ghanadhara, Gandhara, then Kratimati Dhara, Akratimatrik Dhara, then Ghanmatrik Dhara, Ghanmatrik Dhara, and then three dyadic sequences are also there, namely Dvirupa Vargadhara, Dvirupa Gandhara, Dvirupa Gandhara. And here you can see the symbols and the sequences in the form of set, and the general term of each sequence is mentioned here. So the natural number is represented by n. The general term is there n, and then 2n is the samdhara. Similarly, 2n minus 1 is the vishamdhara. Then kritidhara is the sequence of squares, that is n square. And similarly, we can have the gandhara as n cube. So these are the general terms. You can go through the presentations later on. Next slide, please, sir. Then I'm directly coming to the dyadic sequences. I'm not going to discuss these different rest of the 11 series here. And in this sequence, dyadic sequences, the Dvirup Vargadhara, called as the dyadic square sequence. There is a very important sequence. This is a very important sequence because of many large number belongs to the sequence. The first term of the sequence is 2 power 2, that is 4, and successive term is the square of the preceding term. The sequence can be represented as the set U given by 2 raised to 2 raised to 1, means 2 to the power 2. Then next term is 2 power 2 raised to 2, and so on. So here on simplification, the set can be given by 4, 16 to 56, and the general term is given by 2 power n, and goes up to k. The last term is k. So here this k is denoting the ultimate infinity. It is considered as the Keval Gyan. Further, Nemichandra makes an important statement that in the above sequence, as we go a numeral term, we have the Vargashalaka, as Dr. Shah discussed about the Vargashalaka as the log 2 a, and then after numerable, the Ardhached of alpha is there. Then after numerable places, the root of alpha, and again after numerable places, we get alpha, the minimum asankhya, the Jaganya Parita Sankhya. Next slide, please, sir. Next slide, please. Thus, if alpha belongs to U, this capital U is the Dvirup Vargadhara. So if alpha is the Jaganya Parita Sankhya. Okay, so this belongs to U. Then we can have alpha is equal to 2 raised to 2 raised to p, and the root of alpha can be given by 2 raised to 2 raised to p minus 1. The Ardhached of alpha is equal to log of 2 is alpha. So here is the mathematical thing is there. And according to the Nemichandra, we can have the consider alpha as the largest number of the series. Then in the same, it can be represented as p is less than 2 to power p is less than 2 power p minus 1, and so on. All belongs to U. So these all numbers are belonging to the U. And further classification is mathematical treatment is there. And now the next series is given as the Dvirupa Gandhara. Dvirupa Gandhara is known as the dyadic cubic sequence. And the first term of this series is 2 to the power 3, that is 8. And the expression is there. You can represent the series by V. And the first number of the series is 8. And the general term of this series is represented by 2 raised to 3 multiplied by 2 raised to n minus 1. And the last term of the series is k power 3 by 4. Next slide, please. The last sequence discussed by Nemichandra
is the Dvirup Gandhara, Dvirup Gandhara, known as a dyadic cube of cube sequence. Each term of the sequence is a cube of the corresponding term in Dvirup Gandhara. The term is the cube of Dvirup Gandhara. The sequence can be represented as 2 power 9 multiplied by 2 power 0, 2 power 9 multiplied by 2 power 1, and so on, and goes up to k power 9 by 16. The first term of the series is 512. From the last three dyadic sequence, it can be observed that this Wn is equal to Vn cube is equal to Un power 9. According to the Nemi Chandra, for every here W, V, and U, we have mentioned this W, V, and U are the dyadic sequences, three dyadic sequences, where W is the Dvirup Gandhara, and so on. We have discussed here. According to the Nemi Chandra, for every term in U, there is corresponding term in W, except the last four terms. The last four terms are k power 1 by 2, power 1 by 4, and power 1 by 8. Because of the reason that the ninth power of k are more than k, which is not possible as we have considered k as the largest number. Therefore, the last term of W, that is k power 9 by 16, is less than k. And the number of terms in W are 4 less than U. Some more interesting relationships between these three sequences were discussed by Nemi Chandra. So if anyone is interested, so they can go through that particular article. Next slide, please, sir. Now, the conclusion of my work is that on the basis of these, we can say that Jain ascent scholars and mathematicians were earliest to give the broad classification of numbers by dividing into three categories. Then Jainas developed the concept of transfinite number before 800 AD, while the basic ordering of the physical actual infinities could have been developed as early as the 300 BC. Jainas were the first to claim that not all the infinities are equal. On the other hand, the Cantor solved this infinity concept in the year 1873. There is no difference between Asankhya and Ananta, class of numbers. The confusion was due to the different schemes. While Nemi Chandra analyzed the state of positive integers and derived 13 subsequences from it, 3 dyadic sequences, and to the relations between them developed the ground for the theory of logarithms much before than the Napier. So these are some contributions of the Jaina mathematicians, Jaina saints. And so next slide, please. So these are some references. So next slide, please, sir. These are some references. So here I have referred the Dhawla, Trilok sir, and the articles of N. Singh, Gupta sir, Arisha sir, and the article of Navjyoti Singh. So that is my work. And thank you very much. Have a nice day to all of you.
So thank you so much, Dr. Jitendra Sharma. Excellent presentation. You know, they say Eskimos have 50 words for the word ice. 50 words for the word ice. And that's understandable, right?
Yeah.
That's very understandable. And what is now amazing and what you have shown and we have known is that the Dhawla talks about 11 words or types of infinity. So you know that the depth that they went into in understanding those concepts. So thank you so much for your presentation. We have time. We have time for discussion and some question answer as well, up to 5 to 10 minutes or so. What I would like to do is to open up the conversation, maybe have Dr. Anupam Jain give some thoughts and have people, if they have conversation, and again, being very respectful and present the point that you're making, if you agree or disagree with what you heard, and then let the person who had presented reply back in a very short time. So just to exchange and have a dialogue. So Dr. Anupam Jain, maybe a few remarks from you, and then from our other participants, and question answer for another 10 minutes or so.
All the presentation are very good, thought-provoking, and provides an in-depth studies regarding the Jain literature. Professor S.G. Dani explained the geometrical concept which is available in mostly in the cosmological model or the text of the Ganitani Yoga group or Karnani Yoga group, which deals with the structure of the cosmos. They have extracted the things which are related with the geometry. R.S. Shah given an overall development, and he said how beautifully the ideas were conceived by the Jain scholars 800 to 900 years back from they came into picture. And then Dr. Pragati Jain well explained the set theoretic approach which is found in the Dhavla text. As we know that Dhavla is a very big commentary, and it is based on the Shatkhandagam text which is written in the 1st, 2nd century AD. Then Dhavla is the work of the 9th century AD. Even then, it have so many ideas about the set theoretical approach. One very important remark was given by Professor A.N. Singh when he has written the work Mathematics of Dhavla, that the mathematical knowledge which is contained in Dhavla is 3 to 4 centuries earlier, because the knowledge which is available in Dhavla is based on the previous knowledge which is available in the tradition. Regarding the work of Professor Omkarlal Srivastava, he claimed about the prime numbers, and the objection was raised by Professor R.S. Shah. This is very true. We check it, whether up to which extent this can be generalized. It is true that it is non-odd number, but whether they are all prime numbers, it will be checked. That he claimed that Madison prime, and this is the first time found in the Traloksar and the Gomatsar. So this will be tested, as so many times Pankaj Bhai said that we should be very careful about the claim, which if we made any claim here, so we check it, and after that we will publish it. Now Acharyashi's work is very excellent, and he firmly established that before the Aryabhat, the concept of the zero and the pattern of the zero exist in Jain tradition. This is very well established that whether direct evidence is available in a Yogdwara Sutra or not available. Professor R.S. Shah said that whenever number is divisible by 29 times, and we get a number in which on 4th place there is a zero, so this is a perfect evidence, but it is not written there in the form of a hollow circle or a dot. Therefore, very safely Acharya said that before Aryabhat this type of knowledge exists. Now, as I have already said, that there is one cosmological model, another is karmic model, and third one is the application of mathematics found in the Jain logic. So the two papers are based, one related with Professor Kanti V. Mardia and Anthony J. Ruda and Anupam Jesh. They are both related with the logic, and this is very important branch. It is not tracked so far. So whenever cosmological model studies, karmic model is side by side, it is very much essential that we study the logical system, because a lot of mathematics is involved. And the last paper is which is presented by Jitendra K. Sharma, and at present mathematicians face a problem related with the infinity. Cantor's paradox is very common in mathematical world, and only Jain concept of infinity are the details of infinities, classification of infinities, which is available in Jain text, can show the path. I'm not sure what will be the result, but Jitendra Sharma rightly collected the information which is available in the Jain canons, in Aniyogdwara Sutra, in Bhagavati Sutra, in Sthananga Sutra, in Dhavla commentary. Even it is available classification in Tullaya Pannati and in the work of the Nemichand. So now Jitendra collected all the information, and now it is time, with the help of this conference, some people will come forward to analyze the things and evaluate and compare the things with the Cantor's theory. So in my opinion, all the presentation of today are very important, thought-provoking, and can show the path for the scholars who want to do. Professor Shah is very senior person. He widely collected the things from Dhavala, Jay Dhavala, Gomar Sar, Jeev Kant, Karma Kant, Tilok Sar. Not only this, but even the text of the Karma Granthas. Today, there is no paper on the mathematics of the karmic scripture, but it is not possible to cover all the things in one conference or one symposium. So I think it is very good.
Thank you so much, Dr. Anupam Jain. We've had a marvelous set of presentations. I know this has gotten late in the evening at India time. So we would like to conclude today's session tomorrow morning, US time, Eastern at 9 a.m. and at 7:30 p.m. India time. We will begin with a keynote address by Professor Peter Frugel and an excellent set of presentations for tomorrow and also for Monday. So if there are any last remarks, I will ask Pankaj Bhai. But otherwise, Jai Jinendra from Memphis, Tennessee, where I am in US, and looking forward to seeing everyone tomorrow. Pankaj Bhai, any last remarks?
I just had a couple of questions. Again, I want to repeat. I will make all the PowerPoint presentation on a Google Drive, so you can send me the request. I have my email is in the brochure, magnacng@comcast.net. And secondly, again, I would like to again state that we have received the papers from all the scholars, and these papers will go through a very high-level professional review, which will be coordinated by Professor Surinder Jain. And after we have all this paper reviewed and revised, then we do have a plan to publish the proceedings of all the papers.
Okay, so with that, we will conclude. Jai Jinendra, everyone, and Acharya Ji, thank you so much for being with
Namastu
us.
Acharya Ji.
Namastu Acharya.
Mathain.
Jai Jinendra. Jai Jinendra.